A confirmation about the audio, please, guys. If the audio is clear and available, kindly confirm the same. Thank you. When philosophical questions asked, then can I mention geographical aspects where it can be fit in an essay? Absolutely, yes. That is something which is required out of you to be done. Vikram Yamuna. So, hello, a very warm good morning to all of you, and welcome to Baiju's Exam Prep IAS. Welcome to another session of Indian Geography, where today we shall be moving ahead with the portion of the forests, and then after that, we shall be covering the modules of soil and entering into the area of agriculture. So, yesterday, what is it that we studied, or what is it that we looked into? So we had a discussion yesterday about the various features of the rivers in the Himalayan region, the features of the rivers exhibited in the peninsular region. And there we saw that how the Himalayan rivers, they have a particular kind of a speed associated. They move very swiftly and they end up creating different landforms, including the factors involving shifting of the rivers, as well as for the factors when we talk about flooding caused on an annual basis. So we discussed about why flooding happens, why is it that the shifting of the rivers are observed. We discussed about the various different rivers, and then after that we moved ahead and discussed about the interlinking of the rivers, the pros and the cons of interlinking. Then we took a look at the different types of forests that we find in the country, the conditions required, where we observed that if the rainfall, annual rainfall in a region is greater than, let's say, 250 centimeter per year or 220 centimeter per year, you'll find evergreen forest in that region. Then if the rainfall is between 200 to 220, semi-evergreen. If the amount of rainfall is between 100 to 200, you have moist deciduous, and between 70 to 100, you have dry deciduous. And then between around 50 to 70, you have the thorn forests. So these are the various facts and the factors about the forest that we have taken a look at. So today we are going to take a look into the montane forests, both for the northern part and the southern part. And then we are going to take a look into littoral and swamp forests before moving ahead into the state of forest report, which is generated every 2 years. So here, when we talk about montane forests, what do we mean by that? What do we imply by that? Montane forest here refers to the forest to be found in the mountainous regions. Okay, the forest that you end up finding in the mountainous regions, that is what is referred to as montane forest. Now, in the mountainous region, it is not as if you will find only one type of forest to be present or to be existent. From the foothills to the top, if you consider the temperature changes quite drastically, temperature changes and starts reducing with height. And that is a quite a drastic reduction of temperature that we observe, that as you move higher up, it becomes colder and colder. Beyond a point of a height or beyond an altitude, the temperature will become so low that you will not find the presence of trees. All that you will find is the presence of maybe grasses, mosses, lichens, etc., to be dominant in this region. So that is what you find in this area, right? Grasses, mosses, etc. So that is sometimes also what is referred to as the tree line. Beyond a particular height, you won't find the presence of trees. Now, not only does the temperature, but also the amount of rainfall that is received. Amount of rainfall that is received. That also changes as you move up the altitude. So, generally at the foothills, you will find that the temperature is also high enough, around 18-20 degrees Celsius, in that range. And also, you receive quite a heavy amount of rainfall at the region of the foothills. So, that is why many of the times in the region of the foothills, you will end up finding evergreen vegetation. Evergreen vegetation. Right? You'll find evergreen vegetation, deciduous forests in this region also. In certain areas, you'll find deciduous. And then beyond a point that you go, around the height of 2000 meter to 3000 meter elevation, you'll find the kind of conifers in general. Then you will find grasses, and then you will find mosses and lichens. Okay, so that is how it ends up varying. Now, it is not the case that in every foothill you will find the presence of evergreen or deciduous. No, it varies. It depends. For example, in the northeastern region, you have very heavy rainfall at the foothills. So there you can have the conditions which can support evergreen. But the same cannot be said in the region of Jammu Kashmir, because there the amount of rainfall is not so high as is experienced in the region of northeastern states. So it is not going to be the exactly same parameter repeated everywhere, but then broadly I hope you are able to get the trend, that how the type of trees, the type of vegetation, that ends up varying with a particular height. Now, here, basically, in mountainous areas, the decrease in temperature with increasing altitude leads to a corresponding change in natural vegetation. So, here, observe this. Foothills of the Himalayas, you'll find deciduous forests. Now, in the region of the northeastern India, hilly areas of West Bengal and Uttarakhand, evergreen broad-leaved forests are to be found. Trees such as oak and chestnut, and at a height of around 1000 to 2000 meter, already the temperature starts to reduce. So you will find wet temperate kind of forest to be in existence. Why? Because as the temperature indicates a reduction. Temperature indicates a reduction. Okay, so that is basically what you will observe in this case. Now, further higher up that you go, so in this region, around 2000 meter, you will also find 2000, 2200 meter, you'll find cheer pine, chinar, deodar, walnut. These are the types of plants that you find in the conifer category. Now, these plants, for example, take the case of cheer pine. Now, cheer pine is a plant. I understand that you will study this in environment and ecology in significantly greater detail. Just a moment. So, even though you will be studying this in environment and ecology in significantly greater detail about the adaptations that the plants go through in order to survive in various different circumstances, when you talk about plants like or trees such as cheer pine in general, so you will find that they have conical shape in general. Why is it that they have conical shape? You'll find that they have conical shape, and not only conical shape, they also have needle shaped leaves. The leaves are not very broad, leaves are actually needle shaped. And what is the purpose for that? In order to withstand the weight of the snow. Because if the leaves have been broader, if the leaves would have been broader and there is snow which falls on them, then what happens? The leaves are unable to withstand the weight of the snow and they would simply droop down or would break. That is why in areas of heavy snowfall, you'll find that the trees, they will have thin leaves, narrow leaves, in order to withstand the weight of the snow. Because if the leaves are narrow, most of the snow will actually fall down, and this is also the reason why the trees develop a kind of a conical shape, so that all that snow accumulation happens in the lower portion, the base, so that the base is stabilized, the center of mass is stabilized. So that is one of the features that you will find here. Now, majority of these trees that we have listed, majority of them are utilized for commercial purposes. Now, out of them, you'll find that, for example, cheer pine. Now, it also secretes a natural fluid which can be utilized for the manufacturing of biofuel. Can be used for biofuel. Okay. They end up secreting a liquidy substance which can be used for manufacturing biofuel. But then, for example, the state of Sikkim is utilizing this property of cheer pine to manufacture biofuel. But then the disadvantage in that case is that during the dry season, these sticky fluid that is secreted, that catches fire very easily. So they start serving as a kind of a fuel which spreads forest fire. That is why sometimes you will find that in the region of Uttarakhand, forest fire rages incessantly and continuously. Why? Because you will find a lot of conifers, and in the dry season, all those secretions, they end up catching a lot of fire. Okay, so here basically this is something that is, you will that is something that you will find across these mountain ranges, and beyond a height you will find only the grasslands. Remember, in the Himalayas, we talked about the grasslands to be present, right? Beyond a particular height, we talked about the fact that in Western Himalayas, you have seasonal grasslands which are in presence. What are those grasslands or grasses referred to as? Let me see if we remember. What are the grasses that we refer to in the case of the Himalayas, which are seasonal in nature, especially in the middle and the Great Himalayas? It is becoming complicated to understand vegetation because we have visualized. Okay, so have we not revised physiography till now? If we have not revised, fair enough, fair ball game. But we have studied about bugyals, the seasonal grasses which are present. So these are in the category of temperate grasslands that you observe. Then beyond that height, you have alpine forest, pastures, and then mosses and lichens. Now, in the case of the southern part of India, the mountains that you have, they will have a varied kind of feature, because in the southern part of India, the temperature is not very high. The temperature is, or rather, the temperature is much higher as compared to the northern part. In this region, southern part, average annual temperature is higher as compared to the northern mountains. Okay, so average annual temperature is higher. Now, as a result of that, here you will not find the presence of mosses and lichens. Here you will find the presence of grasses at a greater altitude, intermittently spread over. Like these grasses, you will find as a feature across the southern part of India, across the Nilgiris. You will find this as a consistent feature. And here, generally, you will find that these kinds of mountain vegetation are to be found in Western Ghats, Vindhyas, and the Nilgiris in general. Now, here, typically, one of the very unique vegetation that you find in the southern forest is basically the sholas, which you find in the Nilgiris. Sholas in the Nilgiris, Anamalai, and Palni hills. These are basically temperate, wet temperate evergreen vegetation. That is what you refer to as sholas. So they are wet temperate evergreen forests. and that is what we refer to as the sholas. And here, basically, the species Magnolia, Laurel, Chincona, and Wattle, these are something that you find in forests of that region. Now, it is a different matter altogether that in the southern montane region or the southern hilly region, almost all the areas, they are especially in the region of Nilgiri, Cardamom Hills, Annamalai, etc. Almost all the regions are now heavily infested with an invasive alien species of trees. Anywhere, any mountainous area, any hilly region of the southern part of India you will go through, you will find the same invasive alien tree species to be dominant everywhere. And that is the tree of eucalyptus. And eucalyptus is is damaging to the local indigenous variety of trees that we are talking about. So that eucalyptus is growing seamlessly, endlessly across the entirety of the southern part of the country. Now, after that, we have the littoral and the swamp forest. Now, these littoral and swamp forests, they will grow in areas of submerged water condition, in across the coastline, across the beach areas. So that is where they will end up growing. Now, in example of these forests can be taken as mangroves. Now, under normal conditions, when trees will grow in areas where you have a lot of water which is saturated, the trees will die immediately under normal conditions. So, here, the reason that basically these trees are in existence is because they have gone through multiple different types of modifications. So, they can adapt in coastal area, intertidal zones, in all these regions. These trees, that they can not only survive, they can thrive in numbers also. So where are they found? They are found in the coastal states, coastal states and UTs, that is Gujarat to West Bengal, right? All the way Gujarat, Maharashtra, especially the southern part of Maharashtra around the Malvan coastline, then Goa, then Karnataka, also Kerala, Tamil Nadu, Andhra Pradesh, Odisha, around the region of Bhitarkanika, all those areas. Then Sundarbans, one of the largest mangrove population that you have in West Bengal. In all these areas, you will find that. Then other than that, island regions, right? That is Andaman Nicobar, Lakshadweep. Then inland lakes and large reservoirs. Sambar Lake. Where is Sambar Lake situated? In which part of the country do we have the presence of the Sambar Lake? Good, Srihari. Yes, good. It is Rajasthan. Okay. Shreyank, Nilgiri lies in tropical zone. Then how are wet temperate evergreen forest found? I think you received the answer for that, Shreyank. Mangrove trees is found in Sundarbans in West Bengal. Yes, in almost all the states that we have talked about, you'll find the mangrove vegetation. Then, Wular Lake. Where is Wular Lake situated? Very good. In Jammu Kashmir, right? You have River Jhelum flowing through the region of Wular Lake. So, around these areas, around these larger lakes, you will find a lot of these to be present. Chilika Lake. Okay. So, you will find the presence of littoral and swamp forests around all these regions which are spread over. And observe them. They can grow in submerged conditions, they can grow in saline water conditions, they can grow in coastal areas, as a beach forest, as a tidal forest, and also as a freshwater swamp forest. Now, example of these trees, you can take the case of sundari tree. Now, it is after this tree that you get the name Sundarbans, because Sundari tree that is found in large proportion in that area. So that is how you get the name of Sundarbans also. So these trees, mangroves, they typically go through multiple different adaptations, such as viviparity, adventitious roots, salt secreting glands in the leaves, etc. But again, all of those you will study in the portion of environment and ecology if you want to study. So that is where you have to understand that it is because of these adaptations that these trees are able to grow. Now, here, when we talk about the mangrove population in India, you'll find a largest mangrove population in India to be present in the region as of now, in the region of Sundarbans in West Bengal. And Sundarbans overall has got a very large mangrove population. After that, you have major populations which are present in Bhitarkanika, in the region of Gujarat coastline, in the region of southern Andhra Pradesh and northern Tamil Nadu coastline, and also in the Konkan coast. These are the dominant areas. And one of the largest mangrove population of the world exists in which area? It exists again in the Southeast Asian region around Indonesia, because that is where you will find endless amount of islands and island chains. So that is where you'll find a lot of mangrove population also. Okay. Sundri is one of the trees of Sundri is an example of the mangrove, and that is to be found in large quantities in region of Sundarbans. Okay. Now, then we come to the portion which is relevant for your mains exam in this area. In mains, you won't get a question about tell me about this kind of forest type. No, that is a question you won't find. Okay, regardless of many of the times what happens is that people, they tend to they don't want to mislead us particularly, but because of lack of better idea, they will tell you that a question of mains can be framed from here also, here also. So in all that cases, always analyze the type of questions that UPSC is asking, the type of candidates that UPSC is searching for. So UPSC is never going to ask you a question that tell us all about the various different forest type, tell us all about the various different soil types. Such kind of vague class 8 level question UPSC is never going to ask you in the mains exam. So here, in the case of the forest, you will find a question associated with the status of forest in India, and that is basically India State of Forest Report. So it is generated every 2 years, and it is released by Forest Survey of India. So here, this can be a question for the prelims as well, whether it is generated every year, every 2 years, every 3 years, etc. And who releases this report? That can also be a prelims type of question. So India State of Forest Report is released by Forest Survey of India every 2 years, and it started from 1987 itself. And overall, 17 assessments have been completed. And the State of Forest Report 2021, which was released in 2022, that was the 17th report in the series. And now, this year, again, we are expecting another forest report to be generated by the month of December or next year, January. So that is going to be relevant for your examination. Okay. So that is basically the aspect which is important for your exam. Please update yourself before the exams, before the mains exam, also before the prelims exam, when you are reading for the portion of the forest. Now, let me tell you what is it that you need to be careful about, what is it that you need to be searching for. So, first of all, this is the forest report of 2019. You will be asked to chart out a kind of a pattern change, right? That how the pattern is changing from the previous report to this report to the next report? What is the pattern change? So that is something you will be asked to analyze. So what is it that you have to analyze there? So here, first of all, understand that, observe here, you have the classification of forest as very dense forest, moderately dense forest, open forest, and then you get the sum total as the total forest cover. Okay. And then you also have as a separate part the tree cover. So that gives you the total green area. Okay. That gives you the total green area. So that is basically, this is the factor that we have to look out for. Now, overall, what is the difference between the forest cover and the tree cover? What do we mean when we talk about a tree cover? So when we talk about tree cover, it is, and understand this basic aspect, that anywhere where you will find trees, you cannot call them as a forest, can you? If, for example, you come to any particular city, let's say around the outskirts of Hyderabad, you find trees in significant quantity, you cannot call them as a forest. Similarly, let's say you arrive at Bangalore and you cannot call the region around, let's say, central Bangalore as a forest because it has trees. So any tree cannot be referred to as a forest. Any area which has got a set of trees cannot be regarded as a forest. Whichever city you would be living in, it would have a kind of a garden, a kind of a park in between. That would have a greater density of trees. But do you call it a forest? Absolutely not. So, for any area where the region of vegetation is less than 1 hectare, that will be regarded as tree cover. Where the vegetation cover is greater than 1 hectare, and then also you will find that not only the vegetation size is greater than 1 hectare, but also classified by the government as the forested region, those are covered under forested area. It is the state government which declares them. Sometimes the central government can also do that. But the other than that, the regions which have an aerial spread of less than 1 hectare having vegetation, that is regarded as tree cover. So that is the difference you have to be mindful about. Okay. And then the classification of the forest, classification as very dense, moderately dense, and open forest. What is the classification? So here, when we talk about the classification of forest, it is always done based upon the canopy cover. Canopy cover of the trees. What is the canopy cover? So in any area, if you consider the tree population or the vegetation in general, so this portion is what is referred to as canopy. So in a particular area, land area, what is the total canopy cover in that region? So that will give you an idea about the classification of the forest. If the canopy cover is greater than 70%, that is, in that particular land area, almost 70% of the land is covered by the canopy of one tree or the other. So that will be very dense forest. Canopy cover of greater than 70%, very dense. Canopy cover between 40% to 70%, moderately dense forest. Canopy cover between 10% to 40%, open forest, right? So less than 10 to 40% of canopy cover means what? That the trees are almost negligibly present, and the trees are present at very far away distances from each other. So that is open forest. And then scrubland, when the canopy cover is less than 10%, that means that region is dominated by small shrubs, small herbs, small plants, etc. They are the ones which start dominating them. So that is basically how the classification is carried out. Now, in terms of area, the states with largest forest cover in terms of area are Madhya Pradesh, Arunachal Pradesh, Chhattisgarh, Odisha, and Maharashtra. This is the aerial spread of the forests in the country as per the latest report. Madhya Pradesh has got the largest amount of forest cover. And which kind of forest will you find typically to be most dominant in Madhya Pradesh? Take a random guess that which kind of forest cover you will find to be dominant in the region of Madhya Pradesh. Very good, Deepika. So here you will find the domination of, good, everyone. Temperate. Why will you find temperate forests in Madhya Pradesh? I mean, the guess should also be somewhat, calculative guess. So here you will find tropical deciduous to be most dominant. In certain areas, you will find thorn forest to be in existence, western part of Madhya Pradesh in particular, but northern also. But in majority of the region, you will find either dry deciduous or moist deciduous to be dominant factor. Okay, so that is basically the states which have the largest forest cover. Now, the states with largest percentage of area under forest. So largest percentage you'll find is occupied by Mizoram, where almost 85% of the land area is covered by forest. In Arunachal Pradesh, almost 80% of the land area is covered by forest. Meghalaya, you will find around 76%. Manipur, 75 or 74%, and Nagaland again 74%. So these are the percentage coverage of the land area which is occupied by forest. And ironically, these are also the states which are experiencing the highest level of deforestation. The highest rates of deforestation experienced across the country are experienced across northeastern states. And that has got a lot of ramifications, a lot of impact in terms of the not only the biodiversity which is getting lost, but also how the landscape is becoming unstable, because with the loss of forests, the rainfall becomes very disturbed. So rather than receiving, let's say, 2 centimeter of rainfall on a daily basis, regions, they receive 10 days of dry condition followed by 1 day of excessive rainfall. And when you have excessive rainfall in the hilly areas, in the mountainous areas, what kind of event does it trigger? It triggers events such as landslides. Very good. So that is where it triggers landslides. That is why you will find in the northeastern region for the past decade or so, the frequency of landslides happening, that has increased dramatically and drastically. Why? Because of deforestation, leading to a dispersed rainfall, disturbed rainfall condition, leading to excessive rainfall at one time, and landslide. Also, another event that it triggers, because the rainfall has become, let's say, very disturbed, means what? You will have longer spells of dry conditions and shorter spells of excessive rain. So, longer spells of dry conditions means the seasonal streams, the local streams that are present, which have always supplied drinking water facilities, those streams have started to dry up. And excessive rainfall received in 1 day, that will never sustainably keep on recharging the streams. That water is lost. So that is why there is water scarcity coming also due to deforestation. So one event can trigger many such simultaneous events also. Okay. So overall, you will observe that forest cover in India has increased by, from the last report to the report 2021. So as per the report of 2021, forest cover has increased by almost 1540 square kilometer, and tree cover has increased by around 721 square kilometers. So total overall increase from the last report of 2019 has been roughly around 2200 square kilometer in general. So total forest and tree cover of the country is 80.9 million hectare, which is 24.62% of the geographical area. So here, if you observe, earlier it was 24.56, now it has increased to 24.62. And as compared to the previous report, there has been an increase of 2261 square kilometer of the forest, out of which basically you will observe that there is an increase of 0.4%, and the states with the largest increase, that is Andhra Pradesh, Telangana, Odisha, Karnataka, and Jharkhand. So these are the states where you have maximum increase in the forest cover which has been observed. Now, there are certain other highlight. The total amount of mangrove population, the mangrove cover, that is also increasing. And this was also the case in the last report also. So for the past few reports, what has been observed is the trend is that the mangrove vegetation across the country, that is increasing. India is a member of a global organization that we refer to as Mangrove Alliance for Climate. You will study that under the portion of current affairs and under the portion of environment. So Mangrove Alliance for Climate, basically India being a member, India recently became a member of it. This is a forum to increase the mangrove vegetation and population across the world, initiated by UAE and Indonesia. So India has also become a member of that. Now, by the way, mangrove cover in the country has increased by around 17 square kilometer. Bamboo forests have registered a growth of approximately 26% from the previous forest report. And very dense forest, importantly, the very dense forests have increased by 500 square kilometer. It is the increase in very dense forest which is important. That is much more important. The very dense forest area, if it increases, that is useful for the biodiversity and for maintaining the ecological balance. But what is basically observed is that many of the regions, because of the program of afforestation which is carried out, I hope we understand what is afforestation. Afforestation is you artificially, or you start planting trees in an area to create a forested landscape. Now, afforestation programs, they never end up creating very dense forest landscape. They end up creating open, or rather moderately dense. So, in many of the regions, biodiversity is not able to adapt to the moderately dense forest. So, that is why you will find that it is beneficial if the increase of very dense forest happens. Now, around 17 states and UTs, they have achieved the target of 33% of the area under forest cover, but still you have many of them who have to cover a long distance in order to reach that. Now, this 33% should be covered under forest cover. That was provided as per the norms of the National Forest Policy. The National Forest Policy of 1988. Forest Policy of 1988. That set a target to increase the forest cover across the country to 33%. Right? So, around 17 states and UTs, they have achieved that, but many other states, they are still left behind and they have to achieve this. So, this is just a trend analysis, guys. This is just to show you what to write in an answer if the question is framed that discuss about the India State of Forest Report 2021 and talk about the various changes which have been observed since the last report. So these are what you bring to the table. Now, a similar question can be expected next year, because next year a new report will be at the table. So you have to look at these particular factors in the new report also. Okay. Now, the PYQ. CAMPA. CAMPA is compensatory afforestation program that you have. So CAMPA, you don't, that is not the portion of geography in general. Do you have a doubt in CAMPA, Kishan? If you have a doubt, I will happily take that. But other than that, CAMPA is something you cover in polity. So let's take this PYQ. In India, in which of the following types of forest is teak a dominant tree species? Yes, Misty scheme has been introduced for mangrove forest. That is correct. Good. So it is a tropical moist deciduous. Even this year, UPSC had asked about teak and mahua, both of them tropical moist deciduous. Okay. Now, which one of the following regions of India has a combination of mangrove, evergreen, and deciduous forest? Janvi, not everywhere will you find the conifers to be evergreen, right? It is to be present. They are evergreen in certain areas, not everywhere. So it is not the case that, and please understand, when they withstand that heavy snowfall, at that point of time, their growth reduces, their growth is inhibited. And precipitation happens at a higher altitude. And also understand with the lower temperature, the requirement of rainfall is lesser. Okay, when you study about the global biome systems and the different types of habitats that you have across the world, you will find out that in the region of, let's say, the temperate evergreen forests, you receive much lesser amount of rainfall as compared to deciduous forests. But in the case of deciduous, the trees will have to shed their leaves to survive. But there in the temperate region, you have evergreen vegetation. Similar is the case with temperate grasslands also. Okay. So here you will find which of the following regions has a combination of all of them. So it is Andaman Nicobar Island, which has got all of the above factors. North coastal Andhra Pradesh, you will not find evergreen forest. Southwestern part of Bengal, again, you will not find mangrove and evergreen in the western part of Bengal. South coastal Saurashtra, evergreen forest not to be found. So Andaman Nicobar Island are to be found in that region where you find all the other than the thorn forest, you will find every variety of forest, that is evergreen, semi-evergreen, moist deciduous, as well as littoral and swamp, you will find in this region. Okay. Now, after this, we come to the portion of soil and its associated issues. Mangrove Tawfiq is a special kind of a plant, a kind of a tree which grows in marshy landscape, muddy areas, in areas where the water level is high, and the tree grows in submerged conditions. Across the coastal areas and the coastline, you will find a lot of mangroves. So these are special varieties of trees which are there. So now, when we talk about the soil and associated problem, here for the prelims, what is relevant is basically the types of soil, features, and also regions in general, where you will find them. Okay, where they are generally found. Then, after that, types of erosion. Now, in the mains exam, you are asked questions about soil degradation and desertification, soil conservation. Okay. Don't worry, Tawfiq. You will study about mangroves in much greater detail even when we talk about the portion of environment ecology in general, you will study about mangroves in much greater detail. Please understand, just like you have various varieties of trees out there, right? Not all the trees are the same. I hope we have, at this point of time in our life, at least we are able to distinguish that not all the trees are the same. Few are tall, few are short, few are broad, few are narrow. You have conifers, etc. There's a wide variety. So similarly, for the coastal landscape also, you have a unique kind of a tree which can grow in submerged water conditions. And why they can grow in submerged water conditions, as I have told you, because of multiple adaptations that they go through. So what are the adaptations? You'll cover it in the portion of environment in greater detail. Okay. So this is the portion that you have to cover in the area of soil and associated problem. Now, ideally, I would suggest you that when you are studying this, please study this or revise this only after you have covered the physiographic division. In the case of forests, I told you that study this after you have covered the portion of climate. Here I am telling you after you have covered the portion of physiography. Why? Because the soil that you find in an area, that is oftentimes an outcome, or in majority of the cases is an outcome of the topographical features that you find, the type of rocks that you find. So the parent rocks, the bed rocks, that becomes a determinant for the type of soil that you find. So if we have a better clue about the type of rocks in an area, we will have better clue about the type of soil as well. And where do we get a clue about the rocks? From physiography. So always study this after you have gained a clue about physiographic divisions of the country. Now, when we talk about soil overall, how is it that the soil is formed? The soil that we encounter, that we see on a day-to-day basis, how is it that the soil is created? How is it formed? So, soil is created or formed as a result of the breaking of the larger rocks. In an area, you have the larger rocks which are present. Right, let's suppose. Now, these rocks, they will weather down. They will break down into many smaller pieces over a period of hundreds and thousands and sometimes even millions of years due to heat, cold conditions, chemical factors or chemical erosion carried by the rainwater, then biological events and biological actions taken by the living organisms. These larger set of rocks, they break down into many tiny particles. And that is what we refer to as the soil. So overall, understand the basic thing that earlier or in the early stage, this will get broken into larger parts, very large parts. And when they get broken into larger parts, eventually these will also get broken into smaller ones, right? Closer to the surface, they will experience the forces of nature with greater force, so they will get broken into smaller ones. Further, even these portions will get broken into further smaller ones. So, what does that mean? That means that the soil that we see around us, as we go deeper, the grains become larger, the particles they become larger, and eventually you will encounter the layer of rocks in general. Now, a soil supports life significantly. It is very important for life and support of life. It is said that one teaspoonful of soil consists of many organisms, and in many of the cases, more number of organisms as compared to a habitat or a landscape that we see around. Because you will have much and many amount of small microorganisms which are present, small amount of worms, etc., which are present, insects. So it supports a lot of biodiversity, large amount of biodiversity. And it is the ability of the soil to support the biodiversity, to support the plant growth, which ascribes the factor of fertility to the soil. We say a soil is fertile when? Not when the soil appears to look good, not when the soil appears attractive. No. A soil is said to be fertile when it is able to aptly support the plant growth or the biodiversity. Now, what is required by the soil to support plant growth? For plant growth, generally, you need availability of oxygen. Oxygen and availability of water. These are required, and another thing that is required is availability of nutrients. So, any kind of soil or in any place where the soil has these characteristics, the soil is said to be fertile. Okay, where the soil has got these kinds of characteristics, the soil is said to be very fertile. So, ideally, a fertile soil will have an ability to retain moisture, ability to retain oxygen as well. Okay, so greater ability to retain moisture and oxygen makes the soil much more fertile. Greater availability of, let's say, nutrients, organic matter, etc., that also makes the soil very fertile. Now, if I ask you that of two soil types, ones where you have larger grain size, very large grain size, and the other type of soil where you have the presence of very fine grains. Right? Let's suppose. Now, generally, you will find that the ones which have got a finer grain size, they are able to retain greater amount of moisture, greater amount of air as well. So that is why the soil which has got finer grains, that will generally be much more fertile in nature. Okay, the soil which has got finer grains will be much more fertile, and the soil with coarser or larger grains will be infertile. Okay, so fine grained soil are also grained soil. So when you have a fine grained soil, it will have greater retention of air and moisture. And when you have greater retention of air and moisture, that makes the soil fertile. Okay, so that is basically important for the fertility of soil in general. Now, we take a look at the factors affecting the formation of the soil, because formation of a soil is an event which spans for millions of years in certain cases. So how is it that, or what are the factors which influence the formation? So first of all, when we talk about it here, parent rock or bedrock, what is the role of it, and what do we understand by parent rock or bedrock? So the rock which has basically broken down, disintegrated, and broken into many small pieces to form the present day soil that we see. So parent rock or bedrock is important for giving the mineral composition that a soil has, the mineral characteristic that the soil has, the various different components of the soil is given by the parent rock. So this is important for determines the mineral component of soil. Example, we have black soil, which is made up of from what? Black soil is having a unique characteristic because it is made up of basaltic Igneous rock. Very good. Basaltic rocks. UPSC has asked this precise question, that black soil is formed from which of these rocks? So basaltic flood or basaltic lava in general, that is what has led to the formation of black soil. So it is that bedrock or that parent rock which will disintegrate to form that soil, isn't it? That bedrock will lead to the formation of the soil eventually. So that is why bedrock is very important in determining what is the mineral component of the soil in general. Then you have the influence of climate. Now, by climate here, we refer to temperature, temperature, we refer to the amount of rainfall received. Okay. Now, both these factors, they will either accelerate or reduce the rate of weathering experienced. Now, if an area experiences an accelerated rate of weathering, means what? It will be quickly broken down into many small components, isn't it? So when the weathering rate of weathering is very high, it will be quickly broken down into many smaller components out there. So that is why when we talk about the climatic condition, this influences the property of the soil and also the rate of formation. Influences the rate of formation and the property of soil. For example, igneous rocks which are infused with iron and iron particles. These igneous and metamorphic rocks, when they break down, they form red soil. But then the same red soil or the same rocks leading to the formation of soil in a moist area, in a rainy area, that will form yellow soil. So if the rocks disintegrate and form soil in dry region, the igneous and metamorphic that I'm talking about, they will form red soil. And the same soil formed in moist region will be yellow. Why? Because the iron which gives that red color in the soil, in the presence of moisture, that iron gets converted into hydroxide form. And iron in the hydroxide form is something which imparts the yellowish color. So that is why you'll find the yellow soil to be present in the rainier areas. So you have red and yellow soil. We'll talk about it in detail. Okay. So that is basically the case of climatic condition. Then vegetation and other forms of life. When we talk about vegetation and other forms of life, they contribute to the organic component in the soil, the organic nutrient and the organic minerals present in the soil, that is controlled by them. So they control organic component of the soil. Okay, that is what they end up controlling. Then you have the and organic component in the soil. If a soil has a greater percentage of organic component, means what? It means it is much more fertile. A soil which has got lesser component of organic materials means it is infertile. So greater the vegetation that you find in an area and the soil formed in that region or the soil present in that region, over a period of time the soil becomes much more fertile. Then the time. So time is an important factor. Greater the time taken for the formation, what do you think will be the grain size The grain size of the soil, will it be larger or smaller? If the time taken is very high for the formation, the grain size will be larger or grain size will be smaller? Very good. It will be finer and smaller. And when the grain size is smaller, what can we say about the fertility? The soil will be fertile or infertile? The soil will be very fertile. Okay, so that is where, with time, greater time consumed for formation. So greater time consumed for formation means what? A greater degree of weathering has happened. The rocks have been broken down furthermore. So more amount of weathering has happened. So greater time consumed for formation means finer particles. Finer particles mean you have greater fertility, or the soil in general is more fertile. Then you have actions of running water, wind, and glaciers. How will they contribute, or how is it that they will end up managing the formation of soil? So, all these agents of nature, they carry out erosion and deposition, isn't it? They erode materials from, or they erode the rocks. The larger rocks, they are eroded. And when they are eroded, so the minerals which are present in those rocks, they are also eroded, and they will get deposited somewhere else, isn't it? So that is where the erosion and deposition part is contributed by the aspect of running water, wind, glaciers, etc. Now, these deposited soils that you find, do you think it will be fertile or infertile in general? In general, I'm not talking about exceptions. These deposited soil that you find, they will be fertile or infertile? Very good. It is fertile, right? Because they bring about accretion and accumulation of minerals from various different areas. So these agents of nature, they are responsible for the factor of erosion and deposition, and they bring about the factor of fertility associated with soil. Then activities of decomposers are also relevant. Now, we talk about the activities of decomposers, again, what are decomposers? Decomposers are those set of organisms who carry out the process of decomposition, who decompose a particular organic material. Decomposition in itself is broken down, or is basically consisting of five various stages: fragmentation, leaching, catabolism, humification, mineralization. So decomposition is important for the presence of organic materials in the soil. So when we talk about decomposers, it is important for organic component, or controls the amount of organic components in the soil. Parasitic, in what sense parasitic? No, decomposers generally they belong, for example, you have certain fungi, they will come under the category of decomposers. Then, for example, you consider take the case of the most common decomposer that you will find is mushroom, worms. These all come into the category of decomposers. So that is something that you will find. So they will break the materials into smaller pieces, allow an easy digestion by the various microbes. So that is basically the role of decomposers. Again, something that you, all this portion of biogeography that you see, because the syllabus has been diversified to such an extent and UPSC wants you to go into such depth, all these portions are covered in distinct detail under the portion of environment and ecology. That what is the rate of decomposition, what is or where is it that you will find higher rate of decomposition happening, all these factors, that is covered in the portion of environment. Now, overall, when a soil is formed, so you will observe that the soil has got various different layers associated in terms of the properties, what is referred to as a profile. So basically, it is, in majority of the cases, the soil that is created or that is formed, you'll find that it is a result of the weathering action, where a larger rock piece is broken into smaller one, that is further broken into multiple smaller ones, and that is how eventually the soil formation is present, or the soil is experienced or observed by us. Now here, if you take a look at it, excuse me, if you take a look at it, the topmost layer of the soil or the upper portion of the soil, that is the one which is going to be the most fertile layer. Most fertile layer. And this is where all the organic materials will be restricted into this region itself, because in the lower layers, where will you get the organic component? So all the organic component will be present in this region, in this layer, and also along with that, you'll find the finest particles to be present. As you go to the depth, the particle size keeps on increasing, so the finest particle is present here. Finest particles are to be found in this particular area, this particular stretch in general. Okay. Now, after this, we come to the classification of soil, the different types of soil that we find across the country. Now, here, you don't have to start rote learning each and every type of soil that we study. Only the four major types of soil that is asked by UPSC also, that is something you have to cover. So, what are those four major types of soil that you have to cover? You have to cover alluvial soil, black soil, red and yellow soil, and then laterite soil. These are the important soil types that you have to concern yourself with for the purpose of examination. For the purpose of knowledge, you want to read any number of type of soil, you can read, but this is where UPSC is largely restricted to. So, the soils that we have, what is it that you have to understand in that? Once again, show the factor of soil formation. Okay, for a brief moment, I'm putting this slide on. So, when we talk about any kind of soil, what is it that you have to study about for the examination? Where it is to be found, why it is to be found in a certain area if it is, and also the mineral composition. That is something that you can ignore to learn, because that mineral composition will be oftentimes very randomized, so not always advisable to learn all of those minerals, but a general idea would always benefit you. In general, if I tell you a statement or if I ask you a question, which of the soil type in India do you think it will be rich in nitrogen? What do you think will be the answer of that? We have discussed this question already. So, which soil type do you think will be rich in nitrogen component? Hmm. Few of you have given the correct answer. Many of you have written black soil. Why do you think black soil? Is it a random guess? Okay. So basically, we have discussed this, that no soil type in India will be rich in nitrogen. Not only in India, across the world, no soil type, majority of the soil type is very poor in nitrogen. So if these logics are in place, you are not required to learn the mineral composition as well, because majority of the times UPSC plays with this trick, that whether this is rich in nitrogen or not. As long as you are able to see the larger picture that none of the soil types are rich in nitrogen, you get a clearer understanding. Now, why is it that the soil types, they are not having significant quantity of nitrogen? Why are they poor in nitrogen, all the soil types that we talk about? That is because nitrogen that we have in the atmosphere, that is non-reactive. The N2 form of nitrogen that we have, that is non-reactive. And that is why it does not interact with the various surfaces or rocks. So the surfaces and the rocks, they don't have any nitrate formation. And because they don't have nitrate formation, the soil which is created, that will also be poor in nitrogen. That is why, what do you need to do? You need to apply nitrogenous fertilizers such as urea. Or naturally, we can take help of nitrogen fixing bacterium and nitrogen fixing microbes in general, for example, rhizobium, clostridium, etc. So they will fix the natural nitrogen into the soil by the process of nitrification, where they convert that nitrogen into ammonium ions, that is NH4, and then it is utilized by the root nodules. In general, when we talk about plant species such as pulses, peas, grams, etc., all the types of pulses, all these plant species, in their root nodules, they will consist of nitrogen fixing microorganisms. And that is why these plants, which come under the larger category of legumes or leguminous plants, it is always subscribe or it is always suggested to grow these plants in order to retain the soil fertility naturally, so that the soil can retain its fertility naturally. Okay. Now, here, India has varied really feature, landforms, climatic realms, and vegetation types. We have different types of climatic conditions, different types of landforms, etc. So obviously, the soil type will also be very varied. Okay. Now, uh, isn't it we can add nitrogen to any soil? That is why we apply urea, isn't it, Amrit? You can add nitrogen. That is why we use fertilizer. Kishan, the layering of soil is also found in soil of permafrost. Yes, always. So that is basically, when we talk about the type of soil, we have a large variety of the types of soil. Why? Because we have a variety of climatic conditions, variety of various different temperature conditions, various different physiographic conditions. So the soil form will also be very different. Now, let us take a look at each one of them and let us try to understand where they are formed. And then eventually we'll try to gauge a larger picture where you don't need to learn all of it, where in the map you can depict it on your own if need be. So when we talk about alluvial soil, now without reading this, I understand many of you have the bad habit of reading the PPT meanwhile something is spoken. So I'll switch over the PPT here. So without reading it, think about it. Alluvial soil formed as a result of what? Formed as a result of deposits. Deposits brought by whom? Deposits brought by rivers in general. So, if we talk about the regions where they can be found naturally and absolutely organically, if we think about, where do you think we can find them? One, where all the rivers they carry out the deposit in the northern plains, right? Right from the region of Punjab, Assam, or Punjab, Haryana, all the way till Assam, Brahmaputra plains. So, Indo-Gangetic and Assam plains, Tushar, but sir, soil releases nitrogen. Example, black soil, nitrogen fixing bacteria. Hmm. Please elaborate what you have written, Tushar. Are you trying to say that black soil naturally releases nitrogen without any nitrogen fixing bacteria? Are you trying to convey that? Please clarify that. Akula, desert soil are very finer. Does it mean they are very fertile? Desert soil, have you seen the desert soil? Or are you talking about the sand that you have seen in the movies, the fine sand that people play with in the movies in the desert? Are you talking about the sand or have you seen the desert soil? Desert soil is not fine grained. Sand is fine grained, right? So, sand, when you talk about, how can sand be fertile in the sense that does it have availability of water there? Absolutely not. So all the minerals which are present, they are naturally lost there. So sand will not be very fertile. Now, when you talk about actual desert soil, they are coarse grained, right? So that is where I understood that you would have been talking about sand. So coarse grain, they will not have the greater retention of water. All that water will percolate, will seep down. In the case of the fine grained soil, the particles will stick together in the presence of water. Okay. Okay. So Tushar, you have not clarified yourself, so I gave you time. So please understand again. I will repeat it again, regardless of wherever you have read it. Okay, you might have read it somewhere, here, there, etc. Note this somewhere, verify it later on. Okay, verify it as much as you want. Understand the reason. I'm not stating a fact here, I'm stating the reason. And that reason drives the fact. As long as the reason is correct, fact will automatically fall into the place. What is the reason? The atmosphere consists of large quantities of nitrogen, but that nitrogen doesn't react with the rocks. Oxygen reacts with the rocks, carbon dioxide reacts with the rocks. Oxygen forms oxides, carbon dioxide forms carbonates. Nitrogen does not readily react because it is inactive, it is inert. As a result of that, the rocks, they don't have nitrogenous compounds. When the rocks, they don't have nitrogenous compounds, the soil which will be formed as a result of disintegration will also not have nitrogenous compounds. So that is why majority of the soil type, and we will see it as we talk about the characteristic features of all the soil types, majority of the soil types, they are very poor in nitrogen. Now, all the knowledgeable people amongst you who are consistently typing about rhizobium, clostridium, nitrogen fixing bacteria, that is not naturally found in across the regions of the soil. It is found in certain cases and in the root nodules of leguminous plants that I have already talked about. That it is in the root nodules of the leguminous plants where you find these nitrogen fixing microbes. Do you think you will find nitrogen fixing microorganisms in the garden soil that you will dig around you? Do you think nitrogen fixing microbes will be found on the roadside soil that you find? That nitrogen fixing microbe is not very common. That is why, in order to augment the fertility of the soil, you apply urea. That is why, across the globe, if you take a look at it, urea is the most consumed fertilizer across the globe. Why? Because majority of the soil across the globe, they are very poor in nitrogen, and the presence of nitrogen fixing bacteria, that can never be regarded as the natural nitrogen presence of the soil. That is artificial. As long as the microbes are there, they will produce or they will fix that nitrogen into ammonium by the process that is nitrification. But the moment they are not present, nitrogen content won't be enriched. Is that understood? I read it in test series that soil releases nitrogen to the atmosphere. Example is nitrogen fixing bacteria. That is a process of denitrification, my dear friend. So nitrogen fixation, nitrogen cycle, when you study in the portion of biogeochemical cycles, there's a process of nitrification where the atmospheric nitrogen is converted into ammonia, and then there's a process of denitrification whereby the ammonium ions, they are converted into atmospheric nitrogen and released back into the atmosphere. Okay, so whenever you come across any such facts, please just don't rote learn it. Never rote learn it. Try to understand why it is stated. What is the reason? If the statement is saying it releases nitrogen, how will it release nitrogen? So study that and then move ahead. Otherwise, the rote learning will not carry you very farther ahead. Okay, so I hope that is something that we have understood now for all of us. Now, after this, coming back to the portion of alluvial soil in general. So, alluvial soil to be created by what? Is created by deposit. Where is it that you find the deposits? So, you find the deposits in the Indo-Gangetic plains, the Assam plains. And by plains, we mean the Tarai belt, the Khadar, the Bhangar region, everywhere, wherever the deposits is carried out. So, all the way from Punjab, Haryana, UP, then Bihar, then you have West Bengal, Assam, then also some parts of Madhya Pradesh, some parts of Jharkhand. And also, remember during the time of discussion of physiography, we had discussed about a feature that we referred to as Rajasthan Bagar. I hope you remember that. But in case you don't remember, so these are the small deposits that you find carried out by the streams originating from the Aravalis in the region of Rajasthan, that is, in the north south extent of Rajasthan, close to the Aravalis, you find the deposits as well, extending all the way till the region of Gujarat. So, other than this, you find them in Rajasthan, Gujarat. Other than that, where will you find the alluvial soil? Where there are large deltas, that is also a region for alluvial soil. So large deltas. And where is it that we have large deltas? In the region of eastern coast, all the way from West Bengal to the region of Tamil Nadu, and even extending up to the Malabar coastline. There also you have deposits, right? So in all these areas across the coastal plains, you will find large deltas. Okay, so that is basically the case of the spread of alluvial soil. So what we have done here, see, this list you would find anywhere in any random book that you pick from the market with your eyes closed. They will give you this particular data. But what I want you to understand is where these soils are found and why. If we say Rajasthan, Gujarat, why? Okay, so that is basically, if you understand the why of it, you will never forget the where of it. So the entire northern plains are made up of alluvial soil, extend to Rajasthan, Gujarat through a narrow corridor that we refer to as the Rajasthan Bagar, eastern coastal plains, particularly the deltas, and overall they end up covering close to around 40% of the total area. Okay, so they are very widespread across the country, and they are depositional in nature, transported over a large distance by the major river systems that we have. And these alluvial soils, they are divided into newer alluvium and older alluvium. So when we talk about newer alluvium, here you'll find that the newer alluvium is more fertile, right? Because every year the minerals and the mineral presence is enriched in this. So they will be very, very fertile, and they will be able to support almost all types of crops, especially rice, jute. Jute is one of those crops. We'll talk about jute later today also if time permits. So, jute is one of those crops which requires fresh alluvium every time. That is why traditionally jute would be grown only in those areas which experience very frequent floodings, where the rivers would flood almost every year. It is in those areas that the jute would be grown in larger proportion. That is why even today, look at the regions which grow jute. Assam, West Bengal, the southern part of West Bengal in general, and central portion also around Murshidabad. Bihar, eastern part, more prone to flood. Odisha, parts of Jharkhand, and other than that, obviously Bangladesh. So, all these areas very prone to average annual seasonal floods. It is in these areas that jute will thrive because every time the flood comes, fresher silt is deposited, which has some amount of mineral component that supports jute. And in older alluvium, we know that we have coarse grained crops, for example, maize, pulses, millets, the oil seeds of certain categories, they can grow very well in the case of older alluvium. Okay. Now, here, the alluvial soil overall, observe where it is present. Alluvial soil in all the regions here, in all these areas, observe the presence of alluvial soil. Okay. You'll find the presence of alluvial soil in general. So it is rich in potash, phosphoric acid, and lime, poor in nitrogen, as is the case with almost all the soil types. Ideal for the growth of sugarcane, paddy, wheat, and other cereal and pulse crops. Of the other soil types that you see, alluvial soil is still very fertile because of being characterized by depositional features and deposits in general. They would have various different amount of minerals brought from the various mountains, hills, etc., all of them to be deposited over them. So that is why, in general, they are very fertile. Due to high fertility, regions are intensively cultivated and are densely populated in general. So that is why all the alluvial soil region, not only in India, across the world, you will find that the alluvial soil regions, they are densely populated. Why? Everyone wants to carry out farming, and farming is a kind of an economic incentive, economic opportunity. So large number of people will be living there, size of the farmland will be smaller, obviously because of divisions, etc. And then we come to the black soil. uh okay, Kishan, all foothill states of Himalayas having alluvial soil? Yes, around the foothills you will find them. Anthony, are alluvial soil in Peninsula Plateau? Only in certain cases. For example, the Tungabhadra Doab, right? So in Doabs and in smaller river valleys, there you will find them. Tushar, Tushar, I hope now it is understood. Now it is clear. And Ashwant, is there any alternative instead of urea to add nitrogen content to the soil? So, nitrogen fixing microbes that you have, or you start growing leguminous plants, that is, the plants such as pulses, peas, grams, etc., which naturally will host these microbes, which will enrich or fix nitrogen from the atmosphere into the soil. Okay, I have Kishan, I have a confusion. Please go ahead, ask. Munna, which river creates in Rajasthan? So it is created by river Luni and also multiple small streams which originate from the Aravalis. These are not full-fledged large rivers, but the smaller streams which originate and they carry out deposit. Okay. Shreyank, in class 6 or 7 science, we have studied classification into sandy soil, clay soil, and loamy soil. Yes, but here we study about the characteristic in terms of the geographical distribution of the soil that is still exists in existence. Um, so you said pulse required less rainfall, and where we have alluvial soil, then there they have definitely high water. No, see, the assumption that where you have the presence of alluvial soil, high water content will be available, absolutely incorrect. Because even when you take the case of older deposits, older alluvial deposit, that is Bhangar, older alluvial deposits in that region in itself, there is in many of the cases water scarcity. Because if the river is flowing here, older deposits, let's say, are here 50 or 100 kilometers away, or maybe 25, 30 kilometers away. Where will you get that water availability from? So does not mean if it is alluvial soil, there is a moisture excess. Pulses, they are rain fed crops. They can be grown only dependent on rainfall that is received. Okay. Now, but if they originate from Aravali, so it is in younger state, so how they will deposit? They will come down the foothills. Not They will not deposit on the Aravalis themselves. When they come to the plains, that is where they will start the deposit, isn't it? So now we come to the black soil, which is also referred to as the regur soil. Now, this black soil is formed as a result of the breaking down, the weathering of the basaltic rock, right? Breaking down of the basaltic lava. That is what makes the black soil, which is also referred to as regur. Now, this is ideal for the growth of cotton cultivation and for the cotton cultivation in general. Hence, it is also referred to as the black cotton soil in many of the cases. Now, this black soil, you'll find it has got very, very fine particles which are present, very fine particles. And I don't know if you have ever seen black soil or if you have ever played with black soil during childhood days, but you would have observed one unique characteristic that if, let's say, you try to stick it out or try to give any particular shape to it, it takes that shape provided it has got moisture. So the soil particles, they stick around moisture wherever it is present. So they absorb moisture readily and they retain moisture for a very, very long period of time. That is why in the black soil, in many of the cases, you don't require very frequent watering. You receive rainfall, that rainfall many of the times is sufficient for the growth. So many of the times you don't require frequent watering of the soil. Now, during the dry season, what ends up happening is, so for example, if you consider, let's say this to be the soil region. Now, let's suppose here you have water droplets which are present. Now, what the particles of the soil do is they stick around these water droplets. The particles you will find, the particles they tend to stick around these water droplets. During dry season, anyways, lot of water is not available. So they will try to retain this moisture by sticking around it. And as they try to stick around whatever remnant amount of water is available, in the process, they will open up cracks on the surface. So, in the process of sticking around these water droplets, what they will do is they will open up cracks on the surface. Now, these cracks, they are something which act as a passage or a pathway for movement of oxygen, etc., to the lower regions. That is the purpose why we carry out the plowing activities, isn't it? When you plow the land, why do you plow the land or till the land? So that air inflow can be provided to the lower levels also. So here also, naturally, the cracks when they develop, they allow the air to go through to the lower regions. That is a property of the soil, which is also referred to as self plowing. That in dry season, cracks open up, and when the cracks open up, air penetrates to the deeper level. That is self plowing. So, it is ideal for growing cotton and is also known as the black cotton soil. Climatic condition, along with the parent rock material, are the important factors for the formation of this soil. Now, it is typically to be found where? Wherever you find the basaltic region, that is Deccan Trap, spread across the northwest Deccan Plateau and made up of lava flows. And the regional spread, plateaus of Maharashtra, Saurashtra, Malwa, Madhya Pradesh, Chhattisgarh, and extend furthermore in the region of Godavari and Krishna valleys, that is even in the region of Telangana, in the region of northern part of Karnataka, there also you'll find that. And it is rich in calcium carbonate, magnesium, potash, and lime, poor in phosphoric components, nitrogen, and organic matter. Why is this soil poor in organic matter? Let me know. What do you think? Why do you think the soil is poor in organic component? Good. Because it has got an igneous origin. It is basically derived from an igneous rock. Generally, the soil which is made out of breaking of the igneous rocks, they will not have a lot of organic component in that particular portion. Okay, so that is something. And what is how many of us are not aware where Saurashtra is present, or which is the portion that we refer to as Saurashtra? Hmm. Okay, it is a portion in the region of Gujarat, particularly the southern part of Gujarat that you see, that is oftentimes referred to as the Saurashtra region. Just like in Maharashtra, also you have Vidarbha region. So there also it is in the southern part of Gujarat, that is the Saurashtra belt. Okay, so that is basically the basic characteristic. And during the dry season, what happens is that large cracks open up, and through these large cracks, air can penetrate into the deeper portion, and that is what is referred to as self plowing. Now, because of the characteristic of slow absorption and slow loss of moisture, black soil retains moisture for a very long time. Especially, you will find the crops, the rain fed crops. Rain fed crops are what crops? Which can be grown only dependent on rainfall. You don't need to provide separate irrigation facilities, etc. Only on the basis of rainfall, you can have the crop. So, the rain fed crops can be sustained even during the dry season. So, that is basically the characteristic of black soil. Then we'll talk about the red and yellow soil. Before that, we take a break and we come back in 15 minutes and then we continue. By the way, on Saturday from 6 a.m., we'll have the extra session. The last session of geography will be on Saturday. Okay. You'll receive a notification for that in the mail as well. A confirmation about the audio, please. If the audio is clear and available, kindly confirm. Thank you. So now, I did not understand why no organic matter if it has igneous origin. So if Nisarga understand if any soil has got an igneous origin over a period of time, see, understand igneous rocks, do they have the organic component within them? Obviously not. They are very poor in organic component because they are made up of cooling of lava. So that is why, because they themselves are poor in organic matter, that soil which will be formed will also be generally poor in organic component. So that is the reason. Okay. So coming to the portion of red and yellow soil. So when we talk about red and yellow soil, these are formed by the disintegration of igneous and metamorphic rocks which are present. Now, igneous and metamorphic rocks which have the presence of iron in them, they end up disintegrating to form that red and yellow soil. In fact, the red color that you observe, that reddish appearance is associated with the presence of iron. But here, in areas where you have higher amount of rainfall, in those regions, this reddish color gets converted into yellow because that iron ends up interacting with the hydroxide ions, hydroxyl ions forms a hydroxide, and that gives the yellowish appearance. So if you have the drier conditions which are in existence, then these rocks will disintegrate to end up forming a kind of a red soil. In drier conditions you will have red soil. In moist conditions you will always end up finding the presence and the prevalence of yellow soil. So red soil develops on crystalline igneous rocks in areas of low rainfall. And where is it that you have these conditions? So in the region of the Peninsular Plateau, where you have, for example, the Karnataka Plateau region, for example, the Chota Nagpur Plateau region, for example, even if you consider the Bastar Plateau region, in all these areas, you will find the presence of the red and yellow soil. And typically, those regions associated with lesser rainfall, red soil. In these areas, wherever you have higher amount of rainfall, yellow soil. So in the southern part of the Deccan Plateau and eastern part of the Deccan Plateau, that is on the leeward side of the Western Ghats, you'll find them. And also the Piedmont zone of the Western Ghats. What is meant by Piedmont? Piedmont generally refers to the base of the mountainous areas in general. So in the base on the leeward side, right, on the leeward side, there also you will find the presence of this red soil. Okay. And they are also found in the parts of Odisha, Chhattisgarh. So all the plateau area in general, Bundelkhand region. So all the plateau area in general, you'll find the presence of red and yellow soil. So this soil develops a reddish color due to wide diffusion of iron present in the crystalline igneous and metamorphic rocks. In the crystalline igneous and metamorphic rocks, you'll find the presence of reddish color. And whenever you have the hydrated form of the soil, that is the formation of hydroxides in general, that is when it will end up creating a kind of a yellow soil. So yellow soil will be found in the rainier areas of the plateau. Okay. Now, they are poor in nitrogen, phosphorus, and humus. That is the organic component. So they are poor in organic component as well. Again, why? Because they have an origin from the igneous and metamorphic rock. So that is the organic component that we talk about. Organic component that we generally end up talking about. Now, the fine grained red and yellow soil are normally fertile. But wherever you have coarse grains, larger grain size, generally in drier conditions, you will find larger grain size. So larger grain size that is found in dry upland areas, and they are poorer in terms of fertility, and the nutritional component of the soil, that is lesser. So observe which are the areas where you will find these. So typically the plateau regions. The plateau regions overall, the Chota Nagpur, Bastar Plateau region, Telangana Plateau area, the Karnataka Plateau region, some parts of the Western Ghats also, and some parts in the Northeastern region also. So overall, if you have to, let's say, depict the formation or the distribution of soil across the entirety of the country, understand that first of all, let's say you have to draw this diagram in the examination. Overall, understand that alluvial soil will be spread over in which areas? In the entirety of the northern plains, you will have the presence of alluvial soil. And wherever you have deposits, there you will find the presence of alluvial soil. Isn't it? Then the peninsular plateau. Peninsular plateau will either have the black soil or will have red and yellow soil. Black soil in which region? In the region of the Deccan Traps. Wherever there has been a massive lava outflow, the basaltic lava outflow has been significant. So in those areas, you will find the black soil. And in the other areas, you will end up finding the red and yellow soil in proportion. So that is basically the condition of the soil distribution that you can depict very easily. Okay. I hope that is clear. I hope that is understood, that how you can end up depicting it in the image. You don't need to learn this. Please don't be mindful that here also in small stretch you have black soil, here also in small stretch you have black soil. Don't be concerned by this. In the mains exam, when the time comes to depict it on the rough map, just have a uniform depiction of the Peninsular Plateau, divide the portion of the Deccan Traps as the black soil, the rest of the regions as red and yellow soil. Okay. And Pulkit, don't we find iron in any other type of soil? Not in large quantums. No, not in large quantums to give them that particular coloration. And Kishan, how alluvial soil is sandwiched between black soil in Saurashtra. So remember, while discussing about the physiographic divisions, we have talked about the fact that how initially Gujarat was a kind of an island region. It got connected with the mainland by the deposits carried out by the streams and multiple rise and fall in sea level. That is what has created the region of Gujarat. So it is these deposits which end up creating this alluvial soil. Here, this alluvial soil deposit that you see, this alluvial soil deposit that you see, this one, this is actually carried out by a major river in that area. And can you think about the river which has created the black soil in this particular alluvial soil in this region? Can you think about it? It is Tethys is not a river, my dear friend. It is Narmada. River Narmada creates the alluvial soil. Mahi creates the alluvial soil deposits in this region. Mahi, Sabarmati, etc. They end up creating the alluvial soil deposits that you find in this particular area in general. Okay. Yes, Pranay, Rajasthan Bagar is a plain area. Okay. Pulkit, my question is, since alluvial soil is formed as a result of deposits brought down by the rivers, will it resemble the properties of rocks underlying it? Absolutely not. See, alluvial soil will not resemble the properties of the rocks which are beneath it or which are underneath it, because they are carried out as a result of deposits, right? So such kinds of soil, that is a categorization into zonal, azonal, intrazonal soil. So that is azonal soil, which is which has been brought about, or that soil has been brought from somewhere else. It has not developed there on its own. So that is why the characteristic of the parent rock in the case of alluvial soil will be different. Okay. Igneous rocks contain iron. Why, sir? Please tell. That is basically because, see, igneous rocks, they will consist of variety of various different minerals in general. Almost all the igneous rocks. Because What are these igneous rocks consisted of? It is the lava which comes out. And lava, overall, remember we had seen about the elements which are present across the crust and elements which are present in the interior. We had seen that iron is one of those dominant elements. So that lava invariably will consist of iron. It is that presence of iron in the case of the basaltic rocks in many of the cases, which also remember the aspect of mafic lava, right? Mafic and felsic that we talked about. Now, mafic would be rich in iron and magnesium in general. So, where does that magnesium iron come from? It comes from the interior, isn't it? Only in the case of absolutely felsic lava will you have a very poor quantity of iron, but there also some iron will be present. Okay, I hope that is understood. Yes, Srihari, it also consists of feldspar, right? Is igneous is the source of both red and black soil? Yes, but different types of magmatic material, they end up creating black soil and red and yellow soil. Yes, Deepak, that is correct. It is a grade of that kind of a soil. My question is, since white and yellow slide, show again. Okay. Rahul, I'm unable to understand your question. Nitesh, it will be sent to you by today. Don't worry. Okay. So that is basically about the red and yellow soil. Then we come across another kind of a soil, which also gives you the reddish appearance in general. It will give you slight amount of reddish appearance. And that is the laterite soil. Laterite soil is something that you will encounter generally as a kind of soil which during the dry conditions becomes as hard as a stone or a rock. All of us would have encountered these kinds of soil where the soil becomes very, very hard, very rigid. Okay. Now, these are the types of soil which are typically used for manufacturing of bricks. And in fact, the word laterite in itself has been derived from the Latin word later, which means brick. So it is used in brick manufacturing. Very, very poor in fertility, this laterite soil. Very poor in fertility. Very poor in fertility. Okay. And here you will basically observe that this soil will develop where you have the tropical and subtropical climate with an alternate wet and dry season. That is essential. Alternate wet and dry season. So, what happens in this case? Here, leaching is an event which is very common. What is leaching? Leaching is basically when all the various different components they start seeping down, they start percolating down to the lower level. That is leaching. So, for example, if we talk about any soil here, let's suppose it has got certain nutrients which are present. Nutrients in the form of salts, right? In the form of various different alkalis, salts, etc., calcium, etc., which are present. Now, when there is heavy rainfall, which happens, now what that rainwater will do is it will start dissolving these nutrients, and those nutrients will be drained down, will be carried downwards. So that is why in the soil profile that you see, you'll find a very distinct coloration of the top region, whereas the bottom region, they will generally have a darker appearance because of the soil which has been drained down. Now, this is also what it will end up doing is it will end up making the top portion of the soil that will be devoid of nutrients. Devoid of nutrients. Okay, they will be generally devoid of nutrients because most of the nutrients are drained down. So that is why it is immediately When it doesn't have salt, now when the dry season comes in, everything starts to harden together. And that is where it becomes very, very hard, like a rock or like a stone. Now, ideally, this soil is very unproductive. It is typically to be found in any area where you have an extreme wet rainy season and then a prolonged dry season. You will find this soil in existence. Very unproductive in general. But if you carry out proper soil conservation techniques, if you observe proper methodologies of soil conservation, you'll find naturally it starts getting enriched with various different nutrients which are present. All the various different nutrients, they can be conserved, and then there can be a growth which can be associated. So observe here, observe the distinct coloration pattern, all the various coloration. Observe that the topsoil is drained away of the nutrients. The lower region, that is where the nutrients will be accumulated in general. So that is where, because the nutrients are drained out, because all the nutrients are leaching, that is why the soil will be acidic in nature, and it is poor in nitrogen, phosphate, calcium, in general, very poor. So, after adopting proper conservation techniques, particularly in the hilly areas of Karnataka, Kerala, and Tamil Nadu, the soil is being utilized for growth of tea and coffee, and also in certain cases of Andhra Pradesh, for example, even the growth of tapioca, cashew nuts, etc. That is also carried out. So cashew nuts, they are also grown in the region of Tamil Nadu, Andhra Pradesh, and Kerala chiefly. Okay, so mostly in the southern states, Western Ghats region of Maharashtra, Odisha, parts of West Bengal, and northeastern stretches. In fact, even to the south of Aravallis, that is to the south of Delhi, you'll find a significant stretch of laterite soil. You'll find laterite soil in the region of Tamil Nadu, in the region of the Western Ghats, in the portion of the Chota Nagpur Plateau also. So wherever you have a very distinctly alternate season of extreme rain and dry conditions, this kind of soil develops. They are widely cut as bricks for the usage in house construction. Okay, now laterite soil is fueling karst topography like situation? Not exactly so. In the case of the karst topography, the entire material is dissolved. Here, only certain nutrients are dissolved. Means lower portion of laterite soil is more fertile. No, it is not more fertile. It just has presence of nutrients. The presence of nutrients in itself doesn't mean fertility. Fertility is also a product of the grain size. So in the lower levels of the laterite soil, even though the components are accumulated there, but the grain size is larger, so its ability to retain air and moisture is not very significant. Okay, now then we come across the arid soil. Arid means drier conditions. So these are the soils which basically range from red to brown in color. Laterite soil also has got a reddish appearance, by the way. Reddish appearance. Okay. Now, it is sandy in texture and saline in nature. Salt content in general is very, very high in these areas. And due to the dry climate and high temperature, evaporation is very fast. And that is why the soil generally lacks humus and moisture. Why does it? Because for the presence of humus, what is it that you require? You require the materials to be disintegrated, decomposed. Now, if you don't have moisture, decomposition won't be carried out. So that is why here, no organic component, no organic component as decomposition is absent. Why? Due to lack of moisture. Okay. presence of moisture, air, and a warmer temperature, these are the essential factors for decomposition. If the rate of decomposition is very, very fast, then also all the organic components, they will be particularly and completely decomposed. So no organic component which is left. So all of that you study when you talk about the portions and the stages of decomposition in the very initial chapters of environment. And this year, one of the question was framed from that, directly from the PPT it was, and that was about the organic component in the tropical rainforest, the soil in the tropical rainforest. What is the proportion of organic component in that? So that was a question which was directly picked up from the discussions that we have been having in the portion of environment. So we will study all of this. If we get a chance to interact again in the portion of environment, we'll come across all of this over again. Now, nitrogen is insufficient and phosphate is quite normal in that particular situation. Then when we talk about montane soil in general. Now, montane soil also, just like in the case of the montane forests, here also in the mountainous area, from the lower extent to the upper extent, the temperature will vary, the rainfall will vary, and also in the lower stretches, what do you find? You will find that there are greater amount of deposits which will be carried out by the streams and the rivers which will originate from the mountains. There will be greater amount of deposit, whereas in the upper area, upper stretches, no deposits here, no deposits. Now ideally, when you talk about the deposits which are carried out, now deposits when they are carried out, they are generally in fine particles, smaller particles, isn't it? Deposits are always carried out in smaller and fine particles. Now, can we say that in the case of mountainous areas, in the lower stretches, you will find fine-grained particles, whereas in the upper stretches, you will find coarse-grained, larger particles to be in existence. Okay, so that is why lower portion of the valleys, they will always be very, very fertile. And in mountainous area, generally you will find a variation, loamy and silty on the valley sides. In the upper slopes, you have coarse grained and infertile soil. In snowbound areas of Himalayas, they experience some amount of denudation and there is low humus content, no low organic content. Why? Low temperature. As a result of that, negligible decomposition. Okay. And in the lower valley sites, the soils are going to be fertile. For example, take the case of the region of Jammu Kashmir. Now, I think it was one of you, I'm forgetting the name. I think it was Asif, I think, who asked a question about the type of soil that you find in the region of Jammu Kashmir. Yes, Asif. So basically, for example, take the case of the region of Jammu Kashmir. Now, there again, it is not as if the region of Jammu Kashmir will have homogeneous physiography. It will have a very varied physiography, isn't it? So you will find that at the valley bottoms, very fertile alluvial soil. In general, in the region of Jammu Kashmir, what is the physical property that we observe? We observe large deposits, fertile deposits. And what are those fertile deposits? That is basically the karevas that we have talked about. Very good. At least a couple of us remember this. Majority of us, it seems, we have forgotten the previous portions. So the karevas, they dominate. They are also what? They are also depositional soil. So they will be very, very fertile. Whereas as you go up to the mountainous regions, as you go up the elevation, you will find that there will be larger coarse-grained particles which are present in that area. So that is how it varies from the foothills to the higher up as you go, the type of soil that will vary. Okay. Now, Then we have the saline soil condition. Saline soil. So this is a very unique case of a soil condition, which is also referred to as Usar soil, and this is very infertile again. Now, saline soil formation. This is something that you can also observe, or you can also end up recreating this event in your own household, in your own backyard or your back garden. So take, for example, any flowering pot which is there, right? Or any portion of the soil which is there. Do one thing, pour a glass of water. You will observe immediately all that water is dissolved. All that water is absorbed by the soil. Now, pour one jug of water, large jug. You will observe that excess water starts floating on top. And if you have observed carefully, if not, try it out, you would observe that on that water, you will find streaks of whitish lines which are present. Right? You will find those streaks of whitish lines which are present. And then when the water evaporates, that whitish deposit that harden on the top surface. These are the salts. And excess amount of water, what it does is it pushes the salts on the surface. And those salts then solidify on the surface. They accumulate and solidify on the surface. As the salts they solidify on the surface, that makes the soil very hard. It does not allow for the percolation or the penetration of air and moisture anymore. It acts as a barrier then. So that is where the soil fertility keeps on reducing. So understand this process. So here, if let's say this is the soil and it has got various different nutrients present. Let's suppose there is rainfall. Now, what that rainfall will do is it will start dissolving the materials which are present. The components of the soil which are present, the nutrients which are present, they will be dissolved here immediately, right? Not so excess a rainfall that everything gets drained down, but significant excess amount of water. So all of that will be dissolved. Now, as the rainfall has, let's say, abated, or there is no rainfall anymore, so then what will happen? Evaporation will be initiated, isn't it? So when the evaporation will be initiated, all those dissolved particles along with water, they will try to rise up. When they rise up, it is only the water which will evaporate. Only water which will evaporate. Whereas the salts which were dissolved, those salts would be left behind. The salts which were earlier dissolved, those salts will be left behind, isn't it? This is where you have the left behind salts. Now they end up forming a very hardened layer. And when they end up forming a hardened layer, they won't allow the penetration of air or moisture. And that makes the soil infertile. So in which areas will we experience that? We will experience that in areas where you have excessive or over irrigation. Whenever you have excessive or over irrigation, you will observe the formation of this saline soil. So the poster childs of green revolution that you have, that is Punjab, Haryana, Western UP, all these areas where for in the 60s and the early 70s itself, the government that provided the facility of electrification and people started digging out tube wells. So in all those areas, over irrigation is a common factor. And that is why the soil in those areas that is turning out to be saline. Right? Now, if the soil turns saline, what do you think? Apply your logic. What do you think will be the solution? The soil is turning saline. That means there is over irrigation. And obviously, the soil is unable to retain moisture. That is why all that moisture brings the components back to the surface. So, the solution will be to improve the texture of the soil. That is, make the presence of fine grained particles which will be able to trap that moisture, trap that excess amount of air. Now, how will you improve the texture of the soil? By adding powdered gypsum. Gypsum is one of those components, one of those minerals. When they are added in the powdered form, they not only improve or increase the retention capacity, they also increase the texture of the soil, improving the overall fertility. So here in this kind of a soil, basically, if you will observe, they are to be found in arid and semi-arid regions and in waterlogged and swampy areas. So areas of intensive cultivation with excessive use of irrigation, especially in areas of green revolution. The fertile soil has started becoming very and incredibly saline. And that is why the farmers are advised to add gypsum. Why? To increase, to improve rather, the texture of the soil, and that texture, when you improve, adds or helps retain moisture, okay, and overall improves fertility. Okay, so by adding manure, also see, manure, by adding manure you can improve the nutrient amount. In certain cases manure also improves the texture, but not as greatly as the powdered gypsum does. Okay, and arid soil is created due to extremely dry conditions, Priyanka. When you have extremely dry conditions, evaporation is excessive, that is arid soil. Saline soil does not necessarily need a dry condition. Saline soil, moderate to lesser rainfall, but overt irrigation, excessive water logging, etc., that leads to saline conditions. Why particles move upwards against gravity? That is because of what is referred to as the capillary effect. You would have studied in your sixth or I guess seventh standard science what is a capillary effect, where you would have observed basically a simple demonstration of that is that if you have a glass of water, you take a straw and you close the top of the straw, you just dip it in water. What do you observe? You observe that water fills in that straw, isn't it? The capillary effect is what? Are we aware of the capillary effect, guys? I'm not going to go into the depth of the capillary effect, but are we aware about it? Okay, good. So here, what do? You basically, if you put a very tiny straw here, you will observe that the water level here suddenly starts to go up because of the vacancy created. Something similar happens in the case of the soil as well. Now, the top portion is waterlogged, right? So it is similar to blocking the straw with your finger. And here you have the nutrients and various different pathways, etc., passageways within the soil, isn't it? So those nutrients, they are driven up the passageways just like the capillary effect, and that is where they will end up accumulating. Okay, I hope that is clear. Vetri, if gypsum is added to soil and cultivation is carried, and if we consume same food grains, won't it affect health? No. See, gypsum is present in very little quantities and they are not majorly absorbed by the root nodules. We have larger issues to worry. I'll tell you the issue to worry about. For example, in the region of Punjab, the same process is carried out, leading to the soil being turned saline. And why is the soil being turned saline? Because of excessive use of tube well irrigation in that region. excessive use of tube well. We'll talk about it in the portion of agriculture as well. But just to give you a brief idea about it, so this has been, and please, I would like to humbly request one thing for all of you. Please don't get very touchy in case we are talking about any particular state, any particular region. We are talking about the lacunae or the drawbacks initiated in a region. Please don't get very touchy. I have seen candidates who get so very sentimental. If you say something about their state, they immediately will start attacking all the other states. But you see, in Maharashtra also this happens. In Uttar Pradesh, the condition is worse. Hyderabad is the best city in the world. Understood. Whichever city you are living in, whichever state you are living in, that is the best place to live in the entirety of the world. Not only in the world, in the entirety of the solar system, in the Milky Way galaxy. There is no better place to live in than the place that you are living in right now, okay, or the place that you belong from. Having said that, we need to take a look at the portions objectively. So I hope I don't offend anyone, and even if you are offended, please recap this and look at this particular portion where I humbly request all of you not to get offended. Okay, so now that we have put that out of the way, now we talk about the various regions. So for example, let's suppose we talk about the region of Punjab. Now in Punjab, the rainfall received is very less. The crops which are grown require very high amount of rainfall. So where do you make up for the lack of water? You extract groundwater. Now Punjab, Haryana and Western UP, the rural areas, they received electrification quite a lot earlier as compared to the rest of the central India, northern India and the eastern India. They received electrification a lot earlier. Now what does that mean? That gave power for installation of tube wells. Now, tube wells, they were initially also provided at a very subsidized rate, and people started digging the ground and installing those tube wells. Electricity was free, available at negligible cost. So, what the people they got a habit of, still, if you visit the interior areas in Haryana, Punjab, you will find the same trend. Because in majority of these states, for agricultural utility, electricity is provided at almost negligible cost, which means what? Which basically means that people have gotten into the habit of late in the evening, they will switch on the tube wells, the tube well pump. They will go around, carry out their rest of the work, right? They will have good dinner, they will sleep, and then they will put an alarm around 4 or 4:30 or 5 in the morning. When they will wake up, they will switch off the tube well. So for all that duration, consistently, water is being extracted from the underground, being spread over. Water logs. There is overflow. But then people are not concerned with it. Because who is concerned about what happens underground? Eventually, if the matter comes to it, what will be the solution? They will tell you that the government should take care of it. How the government should take care of it, that is not their problem. Right? But the government should do something so that the groundwater is present. Now, as a result of that, what has happened? In the regions of Punjab and Haryana now, the groundwater consists of cadmium, selenium, and most of all, uranium. Uranium in traces are found in the groundwater or underground water in the region of Punjab and Haryana. So that groundwater, when it is sprayed on the crop field, that crop will take in those particular components with the help of water intake. And that is what we are consuming. The grains that we are consuming, that consists of these heavy contaminants. So that is a point of worry. The gypsum that you add to improve the soil fertility, that is not a major point of concern as of now. Okay, so that is where sustainability in agriculture needs to be achieved. And we need to have a climate smart agriculture which is dependent on the climate of that region. Okay, I hope that is understood. Now, here, when we talk about the factor of soil erosion, what do we understand by soil erosion? Erosion is what? Removal of anything, any substance. When it is removed, we refer to it as erosion, right? Erosion of trust. So There has been a general erosion of trust between India and Pakistan. So erosion is what? Removal of anything. When we talk about soil erosion, it is basically the removal of the topmost layer of the soil. That is referred to as soil erosion. The soil is simply removed. So denudation of the soil cover and subsequent washing down is described as soil erosion. Now, why is it that soil erosion will happen? Why is it that the topsoil will be removed? It can be only because of two factors overall. The first factor is if you have the availability of loose soil. If you have the availability of loose soil, right, which is free to move, only that will be eroded. So when do you have availability of loose soil? Lack of vegetation. When you have a general lack of vegetation, that is when the topsoil will be very loose. And secondly, when you have agents of nature, that is river, rains, etc., move with high speed, right? So the topsoil is being removed, and the agents of, or the topsoil is available to be removed rather, and the agents of the nature, they are moving with swift speed. That also carries out erosion. Now, sometimes you would also have experienced this. For example, if you have a lot of topsoil, if let's say you have a lot of topsoil here, now if the raindrops they start falling, you would have observed that when the raindrops they fall, that creates a small splash. Few grains, few particles of soil, they are taken away. You would have observed this carefully if you observe that. That is also an erosion. That is what is referred to as splash erosion. Splash erosion. So like this, let's say consistently if this event is repeated, consistently over a region, raindrops, they will remove the top layer of the soil. What will happen? There will be a natural degraded region here, isn't it? So that is where topsoil should never be exposed. If the topsoil is exposed, either wind will carry it, or the rainwater will carry it, or the river water will carry it. If the topsoil is covered, it will not be carried. That is why even the farmers, when they harvest a crop, you will find that many of the farmers, they prefer to plant any random plant out there, so that the before the next cropping season, so that the topsoil is maintained, the topsoil is retained. So that is the purpose. Now you have various different types of soil erosion. We take a glance at that. So starting with the basic of what is sheet erosion. Now, this is not oftentimes commonly observed with the bare eyes, or the kind of general observation. Many of the times, you won't be even able to observe where is it that the sheet erosion has happened. What is sheet erosion? So, where you have a very gentle slope is not significant, gentle slope, and you have excess amount of rainfall, lack of vegetation, water will have a flow, it will have a path of flow, and in the path of flow, it will carry the topsoil away, isn't it? So observe here, for example, in this region, water has carried the topsoil away. So from a far away distance, this is something that you would also have experienced, you would also have observed, but from a far distance, this is not clearly visible even, right? It is only when you reach that region, you will find that the topsoil has been removed. And now the coarser grain, the subsoil is being exposed. This is the sheet erosion. Now, next time when there will be rainfall, heavy rainfall, answer this. Next time when there will be heavy rainfall, what is or where is it that the water is going to flow? What is the greater probability? Will the water flow from this path A, or will the water flow from this path B and form a newer pattern? What do you think? Water is more likely to flow from which region? A. Very good. Why? Because here already a kind of a channel has been created. So water will find it easier to flow from here, isn't it? So the next time when the rainfall happens, water will flow from the region of A itself. Now, so when the next time the rains come, water flows from here. This channel will be deepened ever so slightly. It will get deeper, right? More materials will be carried out. This becomes the path for the flow of water. More materials will be eroded. More materials will be carried away. What will happen? This will start getting deeper and deeper. And when it gets deeper, it forms narrow channels. Narrow channels. And these narrow channels, they are what are referred to as rills. So then the erosion that we will observe, that will be categorized as rill erosion. Let's suppose there is a channel which has developed here, a deepened channel which has developed here. Now water will always choose this path to flow. So the next time that it rains, this will get much more deeper, further more deeper. So then these rails will be converted into gullies. These are your gullies. And this is where the water will continue to flow. So in areas where you have these gullies, so the land oftentimes that gets fragmented, that gets broken down into many such smaller gullies in general. And that is where you will consistently observe that the water follows that path only. And the land becomes unproductive. You cannot have any commercial utility of the land then. Why? Because eventually all of that will be drained away and the land will be crisscrossed by many different gullies. And that is what is referred to as gully erosion. Okay, so that is what is referred to as. So when only a thin top layer of the soil is drained away, sheet erosion. And when you have channel which is formed, narrow channel, rill erosion. When that narrow channel deepens significantly, gullies are created. And over a period of time, even these gullies will be further deepened. They will form what are referred to as ravines. They are referred to as ravines. What is also referred to as ravine erosion. So, for example, in the region of the Chambal Valley, if ever you get an opportunity, or if you belong to the region of, let's say, Gwalior, Guna district, and if you have been to the region around Morena, Bamur, in the outskirts of it, or in general, if you have taken a train travel from Delhi, anywhere southwards, right? Maybe Gujarat, maybe Maharashtra, maybe Karnataka, maybe Tamil Nadu, anywhere. The train does pass through the Chambal region. And there you observe a lot of these ravines, which will be very dry. But then they will be crisscrossing the land. And then during the rainfall, everything will be filled with water. And again, the dry season will have them as bone dry. So that basically fragments the land into many smaller portions. And that kind of land is virtually unproductive for commercial purposes. And that is what is referred to as bad land topography. So a region with large number of gullies and ravines, that is basically what is referred to as badland topography. So if you get an opportunity to visit the northern part of Madhya Pradesh, you will observe, especially by train. That is where the train travel gives you a larger landscape view in the short time duration. So by train, if you visit, you'll find a lot of these ravines or gullies to be in existence. Now, then we have what is referred to as stream bank erosion. Stream here refers to the river flow, and bank the sides of the river. So many of the time, as the river ends up flowing, as the river ends up flowing, here the river flow will attack the banks. This is the river bank in general. So the river flow will attack this. Now let's suppose there is no vegetation here. So the river will very easily carry this material away, right? It will very easily carry this material away along with its flow. So observe in this case, observe how the river has been scooping up the materials on the sides. All this area is being cut off, excavated by the river in general. So that is the stream bank erosion, okay, where the banks of the stream, they experience erosion. Then you also have the factor of wind erosion, where the wind is so very powerful enough that it will carry the loose topsoil. Now, where is it that you will observe wind erosion? Wind erosion will be prominent in those areas where the wind is very, in the sense, having a very high velocity. The winds, when they exhibit very high velocity, only then they will be able to carry the materials. Now, where is it that the winds will have very high velocity? In the regions where they don't face much of an obstruction. So, which are the regions where they don't face much of an obstruction? That is in the semi-arid or arid areas, desertified areas in general. So, this is observed during in the region of semi-arid and arid regions where you have lack of vegetation. So that is why erosion, overall, you will observe. If you have to prevent erosion, all that you have to do is bring forward some amount of vegetation so that the soil will be bound. And then, other than that, reduce the speed of water or that wind. If you are able to reduce that, you will be able to stop that erosion from happening. Okay. Now, this is the reason the most common application of this is something that you observe on a day-to-day basis in the roads and the highways that you travel. Now, many of the times, and observe this, you would have noticed this. Obviously, you would not have made a point out of it. You would have noticed this, that when you move across highways in general, many of the times you will find that the highways suddenly have a kind of a dip. The roads have a dip and then a sudden rise, and it will be flat thereafter. And again, suddenly it will be a dip, right? There is not a major dip that your vehicle will be upturned like any kind of a movie, but you will experience that dip in the road certain times. Have you thought about it? Why that dip happens or why that dip is present? See, the common citizenry approaches that government, the government's fault, government's action to do. I am not concerned about it. That is what the common citizen thinks about it. But you are the knowledgeable lot. So, what do you make of it? Why is it that the dip exists in these areas? That is because during the excessive amount of rainfall in these regions from the sides, the soil starts moving away. The soil, owing to the weight imposed on the roads also, the soil, which is loose, simply parts way. So that is why, in order to prevent that, what is done? You will observe that large trees, they are planted on the sides of the roads. Now, while planting of trees on the sides of the roads has got a lot of benefits associated, but then one of the major benefits, all of those who have maybe read civil engineering at some or the other stage in your life, you would have basically read about it, that the planting of trees on the sides of the roads has got one scientific purpose, and that is it will hold the soil, it will bind the soil, and the roots slowly and steadily they extend over. they bind the concrete and the soil as well. They don't allow them to get disintegrated. And that is why next time when you travel on road, you will observe that generally where you will find a lot of trees. Yes, there will be degradation of the road because the trees will have concentrated water consistently falling on a region, but there won't be a major dip in the region where you have a lot of trees. So that is because the soil is held in a place. So if you want to prevent erosion, you have to hold the soil in its place. Okay? I hope that is something that you will be able to associate with your day-to-day lives also. Now we come to the aspect of soil degradation. Now, what is soil degradation? Degradation of anything means reduction in quality. So when we talk about soil degradation, the quality of soil, and what do we mean by quality of soil? Something which gives us good aroma and good perfume like feeling? No. Or something which appears good? No. Quality here refers to ability to support life, ability to support plant growth. So, when we say the fertility of the soil has reduced or the quality of the soil has reduced, maybe the soil has been eroded away, or maybe the fertility in general has been taken away. So that is what is referred to as degradation. So it can be defined as a decline in soil fertility when the nutritional status declines and the depth of the soil goes down due to erosion. So degradation can be carried out either because of soil erosion or decline in fertility. Now, why erosion happens, we have talked about it. But why is it that the decline in fertility will happen? What do you think would be the reason? Why is it that the soil fertility declines over a period of time? So it can be due to over irrigation. Okay. Then over application of fertilizers. Of fertilizers. Right. Then after that, climate extremes. Good. Climatic extremities. Then after that, continuous production, unsustained method of production, continuous rice wheat cycle. You don't allow the soil to recharge its fertility. So continuous production. Okay. Lack of diversification of the crops, the same type of crops that you use, right? The same type of crops which will continue to drain the fertility. So growing of same crops, lack of diversification or monocropping in general. Okay, we can say that these are one of the reasons. Then solid waste pollution, solid waste dumping. In our country, something that unites us from north to south, east to west is what? Is the basic kind of a feeling that we have that the land which is around me, which is not my land, I don't care about that land at all. If it is my land, it has to be clean. But if it is some other person's land, I will throw garbage there. I don't care if there is an explosion happening there. I don't care if, let's say, the land simply erupts out in a volcanic eruption. I don't care as long as it is not my land. So what do we do? Any open space that we find, what do? We throw garbage, right? And that garbage piles up. Observe that in your city itself, in whichever town or city you are living in. If Even construction activities are carried out and that stretches for a long time. You will observe that people start throwing garbage there, right? People will start dumping garbage there. Same is the case with the land also. And that garbage dump, that carries out a kind of what? Leaching activity. And that is where heavy contaminants, heavy toxicants, they end up making the soil uh, contaminated or infertile. So that is basically, these are the basic reasons when we talk about the decline in fertility. Then you have loss of moisture, soil moisture, right? Due to overexposure or overheating, due to overheating, right? Now, over irrigation we have already covered. So these are the factors which will lead to the soil degradation. Now, almost all of them are to be found. See, lack of humus is not a factor which will lead to the decline in soil quality. Humus, if it is not present from the initial days, the soil quality will be, let's say, at X. Now, it is not as if the lack of humus will further degrade it. So, lack of humus, it can determine whether the soil is more fertile or less fertile. But when we say the decline in quality, why is it that the quality declines? So, these are the various different factors which lead to the decline in fertility in general. Now, almost all these factors you observe in the so-called agriculturally productive areas of Punjab, Haryana, Western UP. All the other states that you see, agricultural states, all the agricultural states, they have got kind of a lot of hard work in order to catch up the amount of productivity that these states are generating because of various institutional factors, support framework factors, etc. But Punjab, Haryana, Western UP, they had very fertile soil. They had government support in terms of the availability of canal network, availability of infrastructure, availability of electricity. And now the soil in that region is turning out to be very degraded. If you go to the state of Punjab, at least that is the state that I can talk about. So if you go to the state of Punjab, you talk to the elder population, they will always give you an idea that, in our days, the soil used to be so fertile, you would drop a seed, a plant would grow. But now, without fertilizers, no plants grow. So, slowly and steadily, due to our own activities, due to our own actions, and we have to own up to it. It is not the fault of government anymore. It has not been the fault of government for the past 20, 30 years when we were carrying out unsustainable agriculture. Even today, it is our own fault. And due to that, the productivity is reducing. The soil is turning out to be degraded, and eventually it is going to lead to desertification. Now, what is desertification? So, when we talk about a desert, see, desert areas, they are always synonymous with the kind of unproductive land areas where you don't have much of a biological activity producing many things. So, when the region's soil or when the region's condition turn out to be in such a way that they can no longer support plant or animal growth, that will be desertified. Now, even for the world, the aspect of desertification has been changing. The understanding of desertification has been changing. If you go back to 1992, when you had the United Nations Convention to Combat Desertification, when that body was formed, now at that point of time, our understanding about desertification was simple, that the existing desert areas that you have, they tend to expand outwards. They tend to expand outwards in their periphery. And that is what we would refer to as desertification. Now, why is it that these areas would expand outwards, the existing desert areas would expand outwards? Think about it. How is it that the existing desertified areas would expand outwards? So apply your logic here. when you would have winds in the desert area, the winds would be moving at a very swift pace, at a very fast speed. And these winds, they would carry out the sand and they would deposit it in the nearby regions. Now, when let's say your agricultural field is deposited with sand, now will that have any agricultural productivity after that? Absolutely not. So the nearby area turns into a desert. So the expansion of the existing desert in the peripheral areas, that was thought to be desertification. That is why in Africa, various countries in the African Union, they have come together to construct what is referred to as the Green Wall. Have we heard about the name Green Wall? Any of us? Good. So, what is this Green Wall? Is it going to be a large wall green in color? No. In order to prevent the expansion of the Sahara Desert, the endeavor is that in the southern boundary, in the Sahel region of Africa, we will plant a lot of trees. And those trees will prevent or will, in a way, lessen the velocity of the winds. And that is where they can prevent the expansion of the existing desert. So that is where the expansion of the deserts can lead to, or the peripheral expansion of the deserts can lead to desertification in the surrounding areas. But in the last 3 to 4 years, our understanding has broadened. We have understood that it is not only the expansion of the existing deserts, but soil degradation also leads to desertification. How? And this is being observed and experienced in the region of Haryana. In certain areas of Punjab also we are experiencing them. How? So when you have soil degradation which happens, so lesser ability to support plants, isn't it? When lesser ability to support plants means what? Over application of fertilizers. And here also the awareness level is particularly low. Over application of fertilizers. How much amount of fertilizers need to be added? That awareness level is very low. For example, in general, when we talk about NPK, these are the nutrients required by the soil, isn't it? What is this? This is nitrogen. This is phosphate or phosphorus. And this is potash or potassium. Now, ideally, these should be applied in the ratio of 4:2:1. For every 1 unit of potash, you need to add 4 units of nitrogen. And nitrogen is supplied by what? By urea. Now, urea is heavily subsidized, available at a very cheap rate. So, the mentality which works is that, okay, if I cannot get phosphate, I will apply 2 more bags of urea. Anyways, it will help the soil. Last year, I had applied 4 kgs of urea. I got 40 kgs of rice. This year, I will apply 10 kgs of urea. I'll get 100 kgs of rice. No, but that is not how it works. So, the Down to Earth magazine had conducted a detailed study where it was found out that in Punjab, the application of this is in the range of 34:8:1 or 36:8:1. So for 1 unit of potash, people are adding 36 to 34 units of urea. In Haryana, it was found that the ratio is around 27.5:6:1. So think about it, that how in a disproportionate manner we are applying consistently more and more chemical fertilizers. And what do the fertilizers do? When you apply excessive amount of them, what do? They will take in all the moisture, and also many of the microbes which are present, naturally found in the soil, they die immediately. Immediately, all the microbes, they start dying. So the biological fertility of the soil is taken out of the window. So over application of fertilizers means what? Means you have further degradation of the soil. Now, when the crops, they are not, let's say you are not applying the fertilizer, means no ability to support natural vegetation. And that means topsoil is exposed. When the topsoil is exposed, it leads to what? Erosion. Infertile subsoil is exposed then. Lesser or negligible soil productivity. And that means what? Desertification. So that is how soil degradation oftentimes can lead to a factor of desertification happening. Now, if let's say you have to conserve soil, you have to protect soil. Now, if we know the reasons why the soil is getting degraded, if we know the reasons why the soil is getting eroded, can we not frame the ideas how to conserve soil? It will be just the opposite of it. So, first things first, cover the soil. Cover the soil with the plants. When you cover it with the plants, the roots will hold on to the soil and there won't be loose soil which will be ready to flow. And secondly, reduce the speed of runoff. The speed of runoff, water, wind, etc., if that speed is reduced, its ability to carry materials, that will also reduce, isn't it? So all the measures of soil conservation that you talk about, they revolve around these two factors. And then how to retain the fertility without carrying out degradation? How to retain the fertility? So carry out crop rotation. After, let's say, a season of rice, grow pulses so that natural nitrogen fixation takes place. After growth of wheat, grow, let's say, peas or gram so that natural nitrogen enrichment takes place. Allow the soil some time to regain its fertility. So that is how soil conservation can be achieved. In the hilly areas, in the sloping areas, across the contours, across the lines, you can build terraces. Why? So that the speed of the runoff, that reduces, water stays in a region for a longer duration. And when water stays in a region for longer duration, water will percolate. Groundwater level will also improve. Soil moisture in general will increase. And naturally, you will find plants to be growing in that area. So if you observe soil conservation methodology to prevent fertility, prevent erosion and exhaustion, and improve degraded conditions of soil. So here you carry out contour bunding. What is bunding? Bunding basically refers to building of artificial bunds. That is the physical barriers. So in an area, for example, let's suppose this is the landscape. If there will be rainfall, all that water will immediately drain off with increased speed, carry the topsoil away. So in order to prevent that, what you do is you build bunds here, physical barriers. Now, what these physical barriers will do, they will hold the water. The water stays. And when the water stays, it will percolate. Excess water will overflood this, will start draining. But again, speed won't be very high. Here again, it will stay, it will percolate. So bunding or building of bunds will improve the retention of moisture, prevent soil erosion. Then you have contour terracing or terrace farming. And the most apt result of it that you observe is in the case of the hilly states there where we carry out tea plantation in general, right? Or take the case of southern part of China. Now, southern part of China is a mountainous area, the hilly area, or look at the atlas, you will find that. Now, there also you have heavy amount of rainfall leading to a lot of soil erosion. Now, what was done was China does things on a massive scale. So it forcefully converted all those native lands into step-like features, terrace-like features. And what was the outcome of that? Now that region retains water. Not only has it become water sufficient, but now it can support rice cultivation. A lot of rice is grown. And all that rice has increased the productivity of rice in China in general. Right? So then regulated forestry, grow some forest, grow anything, cover crop, so that the soil is not exposed. Controlled grazing, cover cropping, mixed farming, crop rotation in order to maintain fertility. Cover crop basically refers to that you don't necessarily have to grow a wheat there. You don't necessarily have to grow pulses there. Any crop, spinach, chili, anything that you grow, just so that the topsoil is held by the roots. That is the cover crop. Okay. So that is basically methodologies of soil conservation. Okay. I hope that is understood. Now, from here, UPSC had asked a question and framed multiple questions along the way, but I will frame a question, try to write it down. What is soil degradation? Discuss how degradation leads to desertification. Okay. So here you talk about how degradation of land can lead to. So first of all, you talk about what is soil degradation in detail, right? Erosion can lead to degradation, loss of fertility can lead to degradation. So what can lead to loss of fertility? You elaborate about that. Then after that, how degradation brings about a vicious cycle, which eventually ends up in desertification in general. So these factors you can bring to the table. Are we comfortable up till here? Can you please explain green wall again in short? So green wall basically is a methodology, is a kind of a technique which is being adopted by the countries in the African Union, where in order to prevent the expansion of the Sahara Desert to the southward region, what they are planning to do is they are planning to plant trees across the margins of the Sahara Desert. Now, what it will do is it will break the velocity of the winds. And once the velocity of the winds are broken, eventually what will happen? That desert won't expand anymore. So because it will be the boundary made up of trees, hence green wall. Okay. This, I think you can write even in 150 words, but okay, do one thing. This was a question, even though of 250 words, I want you to test your writing skill. Write it ably well in 150 words. You should have that ability, okay? And this is where the ideal test comes, that I have to write what the question is asking, not what I know. So write it in 10 marks, 150 words. Let's see how you write about it. Okay. Now, after this, we come to the portion of agriculture. Now, agriculture, This is the reason behind the reason behind the this is the reason behind the reason behind okay, it is behind the shifting of NPK system to nutrient based subsidy. Yes, that is also the reason for bringing the soil health cards. That is also the basic concept, that you apply only the manures and fertilizers which are required, not anything and everything. Leaching basically means that you have the materials which are drained down to the lower level. That is leaching. PT soil that you have, so that will be the, as if those are the types of soil which exist in submerged conditions, where you have a lot of water logging which is present, lot of vegetation which is present. So in those areas the vegetation cover will be very high, humus content will be very very high, because there is significant amount of organic decomposition which happens. Contour means a line which is present. A line is referred to as, a sinuous line is referred to as a contour. ARMs you should study, Lakshmi. You should try to get through the ARMs. NPK basically nitrogen, potash, phosphorus, and potash. These are the nutrients which are required by the plants for growth. Can we make soil acidic and basic as well? Yes, we can. Um, Nisarga, I've heard winds carry sand from Sahara to Amazon, provides phosphorus, helps in growth of plants. With the green wall, won't. No. Green wall is to the south of the Sahara. Acha, the question is, can leaching activities make soil acidic? Generally, it makes acidic only. ARMs you will get, Amala. You can get the ARMs, right to us at IS Live. Do we find alluvial soil in valley bottom? Yes, we do. Uh, then should India need to make green wall around Rajasthan? We are already in the way of doing something very similar. What can be the causes for desertification other than degradation? So the other reason can be expansion of the desert landscape by wind erosion. The other factor can also be that climatic conditions leeward side of a particular region, less rainfall, and maybe the cold currents, the cold oceanic currents, they also end up creating deserts. So all these basically are the case of desertification. Shivani, is that wasn't that your question? So you have a question, another question. Why, sir, do not reply my doubts? Because the questions that you ask are very difficult. That is why. But on a serious note, I have just replied to your doubts. Okay. And okay. So now we talk about the portion of agriculture. Now, in this portion of agriculture, this is going to be relevant both for your prelims as well as for your mains exam. In the prelims, here we have the portion of the crop types, conditions required, conditions required, regions where they are present. Then, other than that, newer tech in agriculture. And where will you get that? You get that from the magazines, the monthly magazines that you get. So that is where you will find the newer, the also the Down to Earth magazine, etc. Current affairs, newer tech in agriculture. Question from that is oftentimes asked. In the mains, you get questions associated with issues in agriculture. And that would require you to assimilate the topics which are present, which you have studied in the portion of, let's say, economics also, and the portion of geography that we are going to study. Both of them needs to be assimilated there. So when we talk about agriculture, since your childhood days, maybe your class third or fourth standard, when the first time you would have been asked to write an essay about India or anything about India, I'm sure you would have heard about, or you would have started it with, India is an agrarian economy, or India is an agrarian country, agriculture based country. So we have been agricultural dependent. We have been dependent on agriculture for a very, very long period of time, for thousands of years. And agriculture in our country has largely been for sustenance purposes. Traditionally, if you take a look at it, so the farmers would grow crops in order to feed themselves, right? The farmers, they would never grow crops that, okay, a farmer in Bihar is growing crop that, my friend in Kerala, that person has asked me that he requires maize, so today I will grow maize. No. Traditionally, farming has been for sustenance, for self consumption. Now, it is when the Britishers came in fact, since the time of the Middle Ages, when the Turkish invaders in the form of the Delhi Sultanate, when they came in, since that point of time itself, the aspect of cash crops started coming into the picture, where you grow crops for earning profit. But when the Britishers came in, that is when the real impoverishment of Indian agriculture happened, where the traditional crops were shunned, the traditional crops, they were discouraged, and people were basically incentivized to grow indigo and other types of crops, cash crops in general. As a result of that, what happened? As a result of that, whenever we would be stuck with famine like situation or drought like situation, immediately it would lead to a lot of deaths due to starvation. Over the period of the 200 years of British rule, it is estimated, you would have read it in modern history, it is estimated that many, many tens of lakhs of Indians lost their life. Why? They lost their life out of starvation. They died out of hunger. There can be no further form of torture than to kill a person due to abject hunger. In fact, as late as 1943, when the infamous Bengal famine struck, it is estimated close to around 3 million people, they lost their life due to absolute starvation. So this was the backdrop. Then India became independent. Independent India had a large population, lot of mouths which needed to be fed, but not enough resources, not enough food, because our agricultural system was completely upended by the 200 years of British rule. And as a result of that, we did not have enough food to feed our own citizens. Imagine the plight of the country which doesn't have food. Now, at that point of time in the 50s, we were dependent on the grants given by United States, because immediately after after the World War II, United States was the only sole superpower left in the world at that point of time. Soviet Union was also recuperating, but then United States would supply food grains to the third world countries, underdeveloped countries, as grants. And for them, it would be tokenism that, okay, we will give food to Pakistan, Bangladesh. At that point of time, you did not have Bangladesh. We'll give food to Pakistan, India, Sri Lanka. These countries require food. But for us, it would make a difference between life and death. They had a legislation, that is the Public Law 480, which was passed by the US Congress. Now, as per that law, US was supposed to grant food grains. And immediately when the announcement would be made that US would dispatch two container ships of wheat to India, it would make national headlines here, the front page national headline, that another ship carrying wheat docks on Indian coastline and people would get food. That was the abject and the poor condition that we were in. And in these cases, many of the times, in many of the scenarios, India was forced to toe the line or the thought process of United States because we were dependent on survival. Right? Now, over the span of next few decades, we have reached a situation where in majority of the items, we are not only sufficient, but we are either the largest or the second largest producers of those items. India manages to produce more than 300 million tons of food grains every year. India manages to produce more than 300 million tons of vegetables, of fruits every year. From a country which did not have enough milk supply to feed its citizens, we are now the largest producer of milk and milk products across the globe. When you had the Russia Ukraine war, which broke up last year, now in that case, the wheat supply from Ukraine was stuck. Who came to the rescue? It was India. We are now turning out to not only being the suppliers, but feeders for the world. The world looks upon us. Every year, from a situation where we would be dependent on one ship coming from United States, now the agricultural exports alone, they give us around $50 billion of revenue. Agricultural products alone, they bring about a gross value addition to the Indian agriculture and Indian economy to the tune of close to around $300 billion. That is added, that value is added by agriculture. The entire economy of our neighboring country of Pakistan, that much is added in our economy only by agriculture. So, have we come a long way? Yes, we have. Yes, we have traveled a long way to reach this stage. But that still does not take the reality away from us. What is the reality? The reality is around 50% of the population, more than 50% of the population, is involved directly or indirectly in agriculture till now. And overall, they contribute around 15% to the Indian economy, roughly around 15%, 15, 16, 17%. So, if more than 50% of your population is contributing 15% to your economy, what does that mean? It means there is inefficiency. It means there is a lot of scope to improve. It means the farm income is very, very low, isn't it? That brings about various problems. And those various problems require attention. And for that, UPSC expects the candidates to be very well aware about the agricultural realities, the problems that the country is facing. So while yes, we have a lot of things which we should celebrate about, which we should basically be proud of, the path that we have traversed, that we have come across. But at the same time, we have to understand that in the same time period, China outperformed us. Even today, the productivity, agricultural productivity that you find in China is much higher than what you find in India. So, yes, the issues need to be addressed as well. Okay, so that is where we'll end the session here today. Tomorrow, we will continue with the rest and we will finish the rest of the portion of agriculture tomorrow. We'll try to enter into the portion of minerals and industries also. So that is all from my side today, and we'll take a few questions in between. Okay, and we'll end the class. Uh, Shalu Down to Earth magazine is published monthly, then we need to read on month basis. Yes, the few of the articles, not every article. Um, Shivani, salt of body comes out due to excess sweating, like flowing salt on the surface due to over irrigation. Yes, that is correct. And Amrit, can we say that drones are the future of agriculture? In a way, yes, they can help. What is the benefit of being the feeder of the world if we could not feed the people of our own country? That is no longer the scenario. We are able to feed the people of our own country ably well. We are not able to give them nutrition. That is a different matter altogether. But we are able to feed them. Okay. And how does soil lose moisture? When there is no cover on top and it is exposed to excessive amount of heat, it basically loses moisture. Okay. And mining activities and grazing can lead to decline in fertility. Yes. Rice needs water to be filled, so it leads to saline soil condition. Yes, Neha, that is correct. Pulkit, why? Can you please briefly repeat why we have ups and downs? That is because the underlying soil that simply parts way due to the over the weight which is imposed on top. The underlying soil simply parts way. Anshu, yesterday I attended classes for more than 2 hours, but it shows in my report card. Kindly write to us, contact us on IS Live. Don't worry about that. See, at the end of this, please understand that you have to be very careful about the fact that what you extract out of the classes. Other than that, these things you can take it on the sides. Okay, and uh, Shivani, the chapter of agriculture is not given in Indian Geography of class 11th NCERT. It is present in class 12th. And don't worry, the classes, the sessions that we will cover, more than sufficient. Uh, Desertification means no productivity in the soil. Is it fine to draw a flowchart of list of reasons or factors in any answer and then explain? Yes, that is the thing that you can do. Can we say behavioral change is required amongst farmers to ensure stakeholder mindset and agriculture? More than the farmers, behavioral change needs to come about in the society as well. We still think about farming as a kind of a poor man's occupation in general. Do one thing. Um, this is not the case in many of the families, I understand, but in majority of the families, this is a condition. So, whatever job that you are doing, if that job is paying you good enough, try going to your parents and the society and telling them that you will quit the job and you will take up farming. Observe the reactions that they will give you. Agriculture is taken as an occupation which is menial in our country. And when, unless and until that mindset doesn't change, when will you or how will you have the aspect of productivity coming into the agriculture? Right. So that is an issue. Right. Status of green wall in India and Africa, it is still in nascent stage. So that is where I will restrict. Is agriculture as an optional is good if you have had prior information and knowledge about it. If you have read it previously, it is always a good optional. So that is where we'll end the session here today. In case your questions have not been answered, feel free to get in touch. The SMEs will be here to get back to you, or you can get in touch. So we meet again tomorrow. We have an extra session on Saturday as well. Till that point of time, take care of yourself. Goodbye. Thank you.